Good morning, everyone. Good afternoon, good evening, wherever time zone you are in. Based out of Seattle. Don't look at my background. This is not as sunny, not as bright as you would see it there. I'm very excited to get together for this Global HealthTech Summit. Thank you for Glorium Technologies for organizing this. And personally, not only that technology-wise, I'm very much interested in healthcare, but I've been a patient last 5 years. And I just received a great news. 5 years ago, when I got diagnosed with multiple myeloma, they said, well, it's no longer that it's going to kill you, but we need to manage you all through your life, etc. And I did the standard chemotherapy, shotgun, what I call shotgun treatments, which is great. But then a couple of years ago, I relapsed and I had to go through another treatment. And it turned out to be sorry, I think my camera went away. I'll check it out what's happening with the host. So I would I end up doing the chemotherapy and sorry about the camera. And I call it sharpshooting treatments. That's one of the treatments that I got 2 years ago. And first time in my life, last 5 years, an oncologist said, this could be the cure. I've been free of cancer without any medications or anything like that. And it became a changing environment for me. This is a very important part of the overall health in altogether. In 4 or 5 years, from a disease that needs to be managed and potentially lethal for many years, it became a very important part of the overall treatment. And thanks to the technology and the people who's been running with it. So this is a great place where we get a lot of speakers. Is going to talk with a lot of different areas. And I would like to introduce you to Dr. Ingrid Vasiliu-Feltes. She's an amazing person who's really looking after this kind of treatments, which is going to be a targeted environment. She's an alumnus of MIT, Harvard, Stanford, Columbia University, and University of Miami. If you check her LinkedIn, it's pages of qualifications and awards, etc. But she's very much interested in the quantum computing, and she is looking at the different laws and regulatory frameworks, corporate governance, risk management, compliance, and enterprise digital strategy. And she is one of the leaders out there for medical tech perspective. So I'm very pleased to invite Dr. Ingrid Vasiliu-Feltes, and welcome. And as I said, I'm one of your beneficiary of as a patient for the targeted treatment of the diseases. My multiple myeloma completely, in quotes, cured, and I'm looking forward to hearing your latest information on this new technologies and ethics and the laws behind it.
Thank you so much for the kind invitation and very kind introduction. It is a pleasure to be here with everyone today. And as you already highlighted, I will address a topic that is not only resonating with your inspirational life story, but also with many other patients around the world who are hoping for a new paradigm in healthcare. Today, I will focus on a topic that is truly poised to be the future in healthcare for the next few decades. So please allow me to share my deck in full screen to make sure that you can see it well. Please alert me if you are not able to see the deck. So once again, today we will focus on quantum and AI convergence and how we must orchestrate these two converging technologies as well as other amplifying technologies for the future of precision health. The objective that I have for my presentation today is to explore with you how quantum and AI orchestration will revolutionize the precision health continuum. We will examine how quantum and AI orchestration can fortify cyber ethics for precision health. I will also share a few thoughts on how quantum and AI orchestration can enhance risk management and governance for precision health. And at the end, I will also share a few examples how quantum AI orchestration can augment operational efficiency and secure the ROI in precision health. As we have, yes, can you hear me? Okay, so very important to address the ROI, as we have seen in a recent MIT report. A lot of current deep tech projects, particularly those with AI, have not proven the ROI. So I would like to emphasize today that it is essential when we deploy these deep tech technologies that we also highlight the ROI. So let's first begin with the latest updates around the world about quantum deployments. I often talk about quantum over the last 6 to 9 months, and everybody's asking that why are we talking about quantum when it is actually 25 years ahead? And that is inaccurate. There are numerous hospitals and leading academic institutions around the world who are already actively deploying quantum computation. And here are just a few examples: Cleveland Clinic, Mayo, the University of München, University Hospital in Frankfurt, also in Spain. We have in the UAE very strong efforts on quantum computing for healthcare: Singapore, South Korea, Japan, and Dubai. So just to set the stage that we are at the cusp of this new era for quantum and AI deployments. I would also like to highlight that it is essential to understand how quantum and AI can impact the precision health continuum. And that includes the full stage from design to deployment to monitoring and then long-term outcomes. So let's examine one by one. For precision health, wellness is key. We want to move from sick care to preventive care. One of the main goals for eradicating congenital disorders or other chronic diseases that are plaguing society and humanity is to attain longer wellness and prevent disease in the first place, and also longevity and with a good quality of life, not longevity while maintaining healthcare treatments. So for wellness, you can see that we have a lot of efforts for quantum and AI to invest in research and development optimization that is powered by quantum and AI, and pharma companies are leading the way here. For disease prevention, we have seen tremendous latest advances. Several academic centers are working on preventing and eradicating congenital disorders. So several great results have been accomplished with congenital blindness, congenital deafness, and other congenital disorders. Diagnostics, again, massive investments in diagnostics, and quantum and AI again can accelerate all the efforts that academic centers have been doing for many years. Acute disease treatment, this is under development, but a lot of efforts, again, a lot of research published and initial pilots on how we can deploy quantum and AI computing to help with acute disease treatment. So if we can't eradicate, if we can't prevent, at least let's augment how we can treat disease to minimize morbidity and improve outcomes. Of course, if we can't prevent, if we can't diagnose something earlier, then how can we deploy quantum and AI to actually address chronic disease management, like we just heard also? And there are several efforts here as well, where with quantum and AI complemented with several of the other technologies that are currently having a renaissance, such as nanotech, tremendously important for precision health as well, in addition to genomics. We see great applications, and there is hope for patients with chronic disease. Examples are Alzheimer, COPD, chronic heart failure, which are affecting hundreds of thousands and millions in certain stages of the disease of patients around the world. Last one that I would mention in terms of the precision health continuum is longevity. We have seen significant investments by not only tech giants, but also sovereign health funds and several other impact funds that are investing in longevity, and the dual power of quantum and AI computation and quantum and AI simulation capabilities obviously is of tremendous benefit when we study novel ways to enhance human longevity, once again, while staying healthy, not enhancing longevity while staying in a nursing home or getting treatment. Now that we understood the impact of quantum and AI on the continuum of precision health, let's talk a little bit about the direct impact. So first, I would like to underscore how quantum can impact precision health. We, number one, have to emphasize research acceleration, clinical care optimization. Also, on the administrative side, it's often underlooked. Everybody focuses only on healthcare outcomes, but it can also help tremendously with reducing some of the tremendous exponential healthcare costs that we have been seeing. Operations and logistics, which other industries have already mastered. We want to see improvement in operations and logistics in healthcare as well that mirror other industries. And then, of course, like I highlighted, innovation and ecosystem growth. The other aspect that I wanted to highlight is the role of the AI portfolio in precision health. So after understanding how quantum can impact the precision health ecosystem, we have to highlight that the AI portfolio, the complex AI portfolio, also can affect the same domains, as you can see. So therefore, the dual power will have even more impact. And when we look at the dual power of this converging quantum and AI for precision health, it is essential to see how the quantum simulation outputs combined with multi-omics data and imaging data sets can really help us identify novel biomarkers of disease, can help us with molecular modeling, which will help us find also novel, not only biomarkers, but perhaps novel therapeutic agents, and then also predictive biology to understand who is prone to disease and prevent it before it emerges. For clinical care optimization, once again, hybrid quantum and AI decision can be extremely beneficial for high risk environments that need also high decision making in critical situations such as an ICU or operating room or emergency room. The administrative transformation that I highlighted earlier, and then of course, operations and logistics and ecosystem growth. Now, after we understood how quantum and AI each can impact the precision health domains and the continuum of precision health delivery, I want to talk a little bit about quantum and AI governance. No one likes governance, but it's absolutely imperative to dedicate resources to it. Oftentimes, over the last few years, we have seen the same challenge. All companies are rushing to deploy technology, but forget about governance. And it is really important when we think about quantum AI to start early, not just deploy and try to do governance after the fact. I will try to share some of these thoughts about governance in a structured way and guide what needs to happen at the boardroom level, at the C-suite level, what risk managers need to do for adequate risk governance for quantum and AI, what clinicians need to do, and what auditors in this novel ecosystem need to do. None of these roles will be the traditional roles. Strategically, boards have to allow the type of budget and the strategic roadmaps that are required for quantum and AI orchestration. The C-suite must ensure that ROI is attained, otherwise we're going to have the same failed transformations like we've had with many other technologies. The risk managers need to learn how to function in this ultra-automated hybrid environment, so they'll need completely new training. Clinicians will need to be trained how to understand outputs from quantum and AI multipurpose platforms. And auditors need to understand also how to now function and audit an ecosystem that can process several 100,000 transactions per second in a live dynamic environment. Let's talk a little bit about the business opportunity. So we highlighted, of course, the impact from a clinical health continuum, but we cannot underestimate the business opportunity here. So the boards of large enterprises have already recognized that. Therefore, we see massive investments in precision health. C-suite has to understand how to monetize strategies across multiple ecosystems, because that's another benefit of precision health. It transcends the typical healthcare legacy systems. It will have impact on multiple other industries. And then risk managers, as we mentioned, they need to balance the delicate risk management of compliance and governance of all these innovative multi-purpose platforms without stifling innovation. So that's the main goal of risk managers in these novel ecosystems, to understand how to support innovation teams and support technology deployments, but still not expose the company to unnecessary risks or catastrophic risks. And then, of course, clinicians will also not only need to understand how to function in this environment, but hopefully how to also generate novel business lines, novel revenue streams that never existed before. And of course, exactly like I highlighted earlier, auditors will need to understand how to create transparency and do auditing in real time for quantum and AI. As all of you are familiar, the National Institute for Science and Technology in March 2025 has published the latest quantum protocols and has advised many enterprises to be quantum proof by 2030. For healthcare, actually, HIMSS and HHS have recommended earlier, 2027, to ensure that all our enterprises are quantum proof. So once again, at the board level, this means securing talent, securing budget, securing that quantum proofing is embedded in the digital strategic roadmap. For C-suites, they need to ensure that whatever other strategic execution plans were previously authorized now will incorporate also quantum proofing. Risk managers will have to be trained on quantum protocols. Clinicians will now have to learn how to perhaps function in this novel environment that's maybe initially perceived as a little bit more restrictive. And then auditors will now need to be completely trained in not only quantum and AI auditing, but also quantum proof quantum AI auditing. Here are just a few of the standards, not only by NIST, but also ISO has issued numerous privacy and security standards that are relevant to precision health. And I strongly advise all the teams to study them carefully, because we have novel standards published almost every quarter, and they all have an amplifying effect. If you're able to embed not only the NIST quantum protocols, but also all the ISO standards from the beginning in this new precision health ecosystem, you are poised for success. If you deploy and want to do the standards later, it's going to be very difficult and you're exposing yourself to unnecessary risk. So we recommend thinking about a secure architecture blueprint that would encompass not only the ISO and NIST standards, but also quantum AI and other technologies that can help with that. And I'll emphasize which other technologies can help you with this. One other important element to mention is that genomics datasets and multi-omics datasets and panomics datasets pose unique challenges to healthcare informatics teams. So having the teams trained from the beginning how to integrate clinical traditional HL7 datasets with a novel genomic datasets and other environmental data or patient-generated data or wearable data or bioimplant data or nanotech-generated data is critical for building this novel precision health ecosystem. So at the board level, boards understood that building and investing in precision health will give them the strategic edge and the competitive advantage. The C-suite has to now figure out how to multiply the return on investment through this deep tech orchestration. And then, as we already highlighted, risk management clinicians and auditors need to be completely retrained to function in this environment. We can think about quantum and AI as the orchestration layer for this global precision health ecosystem. And of course, again, those that are in charge, such as the C-suite, and then those that have to monitor all of this as the risk managers and auditors, need to understand where the optimal points of intervention are and the frequency of these interventions in terms of securing this orchestration layer and making sure that it dynamically adapts to all the new regulatory and legal guidelines and still allows clinicians to function and get the outcomes that they want. So let's review the tech stack a little bit. So what are some of the technologies that are currently recommended for this tech stack? Well, of course, agentic AI and quantum will be creating an orchestration layer that's hybrid. We then, of course, have the quantum enhanced decision engines. Multi-agentic coordination is also something that a lot of enterprises that have invested in quantum, like those that I showed at the beginning of the presentation, they're heavily focusing on. So not just agentic AI, but multi-agentic AI. And then, of course, federated ecosystems. Last year, I spoke a lot about federated learning, and I'm going to touch on it again today, how it fits in the quantum proofing of this global precision health ecosystem. Physical AI is also showing great promise, as we have seen a lot of keynotes this year have emphasized not only increased investing, but also the increased impact that physical AI will have on all the healthcare environments, not just precision health, and also all other industries. I would also like to emphasize the opportunities for digital twinning. There are numerous companies who have showcased super successful pilots with digital twinning for precision health. Siemens, GE, Dassault Healthcare Systems, Philips, and NVIDIA or Global Technologies are all showing how digital twins can be leveraged for multiple domains within precision health. And then, of course, as we mentioned, quantum secure device networks are also being recommended. Over the last few months, we have also witnessed an increase in investments in humanoid robots. There are already more than 16 humanoid robots that are trained for healthcare. Many of them are actually trained for healthcare related to elder care and longevity, as well as physical rehab. So it is interesting to see where the field is advancing, but definitely with the fleet of humanoid robots that is predicted to have a huge impact in precision longevity health, it is important to also secure that from a quantum perspective and make sure that we optimize that type of humanoid robotics precision health infrastructure. I mentioned federated learning. So last year, I highlighted how federated learning can really change the paradigm to leverage all the massive data sets we have and increase collaboration between multiple stakeholders without jeopardizing IP rights. Well, similarly now, there are several research advances that show that if we combine federated learning with quantum computing and quantum simulation, we can further augment this capability. And there are great examples for cardiology, oncology, neurology, pulmonology, and even endocrinology, where having this capability of combining federated learning with quantum computation will make major breakthroughs. I highlighted earlier also the trifecta of genomics, multiomics, and AI. And once again, adding that quantum proofing to this type of multi-purpose platforms is essential. There are several, as you are familiar, most likely, the Amazon multi-purpose platform that already combines multiple AI tools with multi-omics capabilities will need to be also secured. NVIDIA also has Clara Parabricks and several new opportunities there for multi-omics and panomics combined with AI. And all of those will need to be quantum proofed fairly quickly, as I mentioned earlier, by 2027. Last, I wanted to just briefly emphasize that if we have appropriate quantum and AI orchestration, we can also amplify cyber ethics efforts. So as we have seen, major organizations have published novel cybersecurity guidelines, novel ethics frameworks, but someone needs to now integrate those, and it's up to enterprises to accomplish that. So once you have teams that are dedicated to have integrated, harmonized cyber ethics programs for precision health, it is strongly advised to also quantum proof those cyber ethics programs from the beginning. Otherwise, you would have loss of ROI, loss of reputation, and spend months trying to fix what could have been done proactively. Once again, there are several other technologies that can fortify this architecture that we mentioned at the beginning. The one that I didn't mention until now, but I've spoken on it before on this very platform in previous years, blockchain is another important technology. As we have seen, the finance industry is accelerating blockchain for trusted AI. Not only IMF and the World Bank and European Central Bank, but more than 118 countries have converted now to blockchain-enabled banking and payment systems. So healthcare must follow. Blockchain can help us have that trusted AI layer, and having the combination of blockchain, quantum, and multi-agentic AI is gonna really give a whole new tech stack for precision health. Last but not least, as I promised, we must focus on operational efficiency and ROI, not just clinical outcomes. All are important. We want clinical outcomes, we want successful research and development, but without showing the return on investment, it will not be sustainable. So quantum optimized resource allocation, AI-driven cost predictability, reduced clinical variability, accelerating productivity gains, risk hedging and capital protection, just like we do in the finance industry or in the logistics industry, must happen in global precision health as well in order to be sustainable. Thank you for the opportunity to share a few thoughts on the future of precision health and how quantum AI orchestration is an imperative. Thank you.
Hi, thank you very much. This was very insightful. I think it was a great start to the conversation that we're going to have the rest of the day. This is a great way of summarizing and looking at the challenges of any new technologies that's coming up. You know, it helps the research, it accelerates, it optimizes the clinical care, but it becomes a very different administration, operations, and logistics perspective. And laws and ethics needs to follow ahead of this improvements. So we'll be very comfortable to share that. And as I said in the beginning, as a beneficiary of this incredible advancements in the technology, allow me to be here healthy and living my stuff. So what is your one thing that if you like to achieve in the like administration perspective in the quantum technology? What is your thought process in there? What is the person needs to think number one thing about quantum technology?
Well, a person, I'm not sure, but the C-suite, definitely, I would recommend tackling revenue cycle management. In healthcare, we have had terrible results with revenue cycle management over many decades, and the finance industry has mastered that much better. So all we need to do is leverage existing knowledge in other industries and apply it to healthcare so that we don't have so much unnecessary costs. We should have only the right costs for the right type of clinical outcomes. But we have a lot of waste, a lot of fraud, a lot of abuse, and a lot of inefficiencies in revenue cycle management in the healthcare ecosystem. So if I had my top pick for the enterprises, C-suite leaders that can make the decision, that would be it from an administrative perspective.
Sounds good. Thank you very much for the insights and great advice. And thank you very much. And I'll be following you on the LinkedIn and different platforms. Thank you. Our next speaker is Blair Butterfield. He's the chairman of the Wind River Advisory Group. He'll be talking about early days of health information technology and digital health revolution that's been happening. He's been in different levels from in the healthcare business, from CEO to different areas, and he's been advising a lot of different healthcare companies, and I'm looking forward to hearing from his perspective about the artificial intelligence, information systems, how it's going to be kind of going to the specifics of my information, and overall how to value the organizations being able to deliver individualized healthcare. Welcome, Mr. Butterfield or Blair, however you prefer me to call you.
Blair is fine. Thank you so much. I hope you can hear me all right. Yes. Sound is good.
Okay. You look good as well. Yeah.
Thank you. So I do have some slides. I will just try to share my screen now and see if you can see those as well. What happened to that slides? Let's see. 1 second. Okay, let's try this again. There we go. All right, so as yeah, you can see that all right?
Yes.
Okay. So a little bit about me. So I have, as was mentioned, about 30 plus years in health IT. I've been currently a senior advisor to a company called LEK Consulting as their health IT expert. I was the president of a company that was owned by Philips, Vital Health it's called. And prior to that, I was a vice president at GE Healthcare. I've sat on a number of different boards, profit and not profit, and currently live in the beautiful western US state of Wyoming. And yes, I took that picture myself from the top of an 11,000 foot mountain on a hike last summer. And that's the Tetons range of Jackson Hole in the distance. So the beginnings of health IT really emerged in the 1960s and 70s. So I'll give you a brief tour of this up to the present day. With the introduction of computerized systems for basic administrative tasks, primarily billing and patient registration, and these systems were optimized for just departmental workflows, in other words, not enterprise, and did not share a common architecture, user interface, or database. So these were all known as best of breed solutions. And the end result was a mix of these non-interface systems that had no reliable way to exchange or consolidate their data. And as networks became more developed and the desire to share information grew, then a tension arose in the industry between adopting what were called these best of breed systems and the early enterprise systems, which could reach across the enterprise to share data and communicate. The trade-off was the best of breed was really highly optimized for specific needs of a specific department, whereas enterprise was more, as I mentioned, enterprise-wide. The contrast was that the enterprise systems had a single database, application architecture, and a common look and feel in the user interface. And they could share data across various departments to give a more consolidated, comprehensive view of the patient record. Eventually, these enterprise systems won out over this battle between the two types, much like Microsoft Office won out in the early days of personal computers between those companies who had developed very specific spreadsheets, word processing, presentation tools, and then Microsoft Office came along and offered all of it with a single look and feel common architecture. So electronic health records, or EHR systems, replaced these paper-based records although at this time interoperability was still very limited. In the early 2000s, there was a digital health revolution. The government played its hand here, deciding to incentivize the adoption of electronic health records for all citizens. This was a huge goal, which I have to say has not yet been fully realized. And in these early days, financial incentives were introduced to motivate doctors, providers, healthcare practitioners to adopt electronic medical records. This was the so-called era of meaningful use. They could get a subsidy to purchase these systems, but they had to share certain data with their patients and with their referring providers. So the goal was a sharing of the basic patient information and to reduce the cost and quality of care by reducing test repetition, which was very rampant when a patient would go from one doctor to another because they had no access to the prior record. They would just repeat the test. And this, of course, introduced a lot of inefficiencies. Also, very important was access to medication histories. Doctors, when we worked on this in the early days, they said if there's one piece of information we would love to have when we see a new patient, above and beyond any other information, it would be their medication history and, of course, their problem lists. So in order to be useful, the data needs to be interoperable and portable. And so there's been a huge amount of effort invested in time and money to make these systems interoperable with each other. And it's actually turned out to be much harder than expected. In 2004, President George Bush mentioned or stated that by 2014, I believe was his goal, all Americans would have an interoperable health record. Well, we're more than 10 years later now, and that's still not the case because the standards to enable that simply didn't exist at that time. They were very efficient for the limited tasks they could perform, but not for the enterprise-wide, region-wide, nationwide vision that had been articulated. And the other problem is that the data that had already been collected in the past, legacy data, was generally non-standardized, so it could not be shared even when the standards existed. And of course, then you have the compounding issue that different service lines, different systems within the hospital have different standards that have been developed specifically for their own specific area, like DICOM for imaging, HL7, CDA for sharing patient records, etc. More recently, HL7 has stepped into the foreground with their FHIR, FHIR standard, as the current preferred standard set for interoperability across core systems. And another very important organization is IHE, International Integrating the Healthcare Enterprise, which has created use cases and profiles which actually allow these standards to be compiled into a use case and then applied for specific workflows that are needed. So this combination of the HL7, FHIR standard, and IHE has proven to be a way to move forward with this very huge project. Now we come to a brief overview of the early days statement of what the goals of electronic medical records would be. And here you can see from HIMSS, this was the Healthcare Information Management Systems Society. What were the goals for acquiring these electronic medical records and the projected date by which they would be achieved? So at the bottom of the pyramid, you see simple collection of data. Then you see a step towards automation where you're documenting workflows. Then you have the helper level, which is providing very basic clinical decision support where you could enter a query and the system would reply back with some suggestions based on information that had been programmed into it. Then you have a colleague level where you actually are getting workflow support real time while seeing the patient to help determine decision trees, protocols, etc. And then finally, the mentor stage, which would be called guided care, where the system is actually able to basically manage the whole interaction with the patient and the physician is there merely to oversee and confirm that the decisions and guidance being created are valid. So obviously this model back then in 2004 assumed capabilities that were not available at that time, but some of these are actually now becoming possible with the admission and generation of AI. So how is that working? So there are three basic types of AI in healthcare. One is machine learning, where you train AI models to find patterns and make predictions using statistical models. Precision medicine models are trained on specific diseases to help predict what treatments may succeed based on the patient's attributes and treatment context. The second type of AI is natural language processing, or NLP, and this is applied in the area using speech recognition, text analysis, and translation to understand human speech to create and classify clinical reports and publish research. These systems, NLP systems, can transcribe provider-patient interactions in real time, expediting clinical documentation, which otherwise takes many hours of the provider's time, usually after hours, after patients have left for the day. They have to stay behind and document all of their case histories and prescriptions, etc. So with NLP, that process is shortened, and now it's possible for them to just dictate or speak interactively with the patient, and the system is listening in the background and documenting. And then, of course, we have generative AI, Gen AI, which utilizes deep learning algorithms to analyze unstructured data and create new content, including text, audio, code, etc. This automates operational work such as insurance prior auths and summarizing hospital discharge instructions, potentially unlocking what's been called a $1 trillion improvement potential present in the healthcare industry. And here you can see that it's actually providing a way to digest the legacy non-standardized data, the unstructured data from the past, and incorporate it into a usable patient record that can actually be addressed using AI as part of an EMR workflow. And I guess we have to come to a brief analysis of what's called the hype cycle. If those of you are familiar with the Gartner hype cycle, this is a process that almost every new technology introduced in healthcare goes through. On the left side, you see expectations, the rise of expectations, and across the bottom axis, the progress of time. And so on the left, you'll see an innovation trigger. A new technology enters the market. It rises to a height of what we would call peak of inflated expectations, that this thing is unbelievable. It will solve all our problems. And, we wish we'd had this years ago kind of thing. The systems are then applied, and it turns out they can't do everything that was expected. And they reach what's called a trough of disillusionment, where it's sort of begun to be felt that maybe we overhyped this thing, maybe it's not really going to do everything we hoped, and maybe it's not going to solve all of our problems. But as people keep working with it over time, this technology will climb what they call the slope of enlightenment and reach a plateau of productivity where it is applied. Its value is not as great as it was initially expected, but it is far greater than it was after that trough of disillusionment was reached. And it becomes an accepted, standardized part of the industry. So this is a somewhat outdated slide, but this is a hype cycle of the top 50 emerging digital health trends. Don't worry about reading all of these. I've highlighted the ones that refer to AI and where they are on this slope of enlightenment versus the hype cycle. And you can see at the emerging end, you have AI in drug design, you have AI in diagnostics beginning to climb the slope, AI in medical decision making becoming partway up. Then you have AI-based prosthetics. This seems to be one which has a lot of hype attached to it at the current time. And then further on, you see the other areas where AI is just beginning to be applied, just beginning to be incorporated. And we will see over time that it becomes a part of that, and it also will reach a plateau of productivity in future years. So to focus in a little bit more on some specific areas of healthcare using AI, in diagnostics, we have ability to analyze medical images with an enhanced capability. Algorithms that can rapidly analyze medical images such as X-rays, MRIs, CT scans, improving the accuracy and speed, I should say, in detecting conditions like cancer, fractures, and neurological disorders, essentially doing the triaging work for the radiologist to show which areas really need to be focused on. Then you have early disease detection. AI systems can identify subtle patterns in diagnostic data, enabling early detection of such diseases as Alzheimer's, cardiovascular disease, and diabetic retinopathy. And of course, automated workflow efficiency. AI reduces the burden on healthcare professionals by automating routine image interpretation tasks, allowing clinicians to focus on the complex cases and improving overall workflows. I recall in my early years doing sales of imaging systems, excuse me, especially PACS systems, which are used by radiologists to review image data. One prominent radiologist told me, he said, instead of documenting every single study that I have to look at with, a whole plethora of different fields that have to be entered and codified, he said, I just want a button that's labeled normal. And if I just hit that button, it will do all the work for me. So this is essentially what medical imaging analysis with AI can do, is provide you a normal button and identify those studies which need to be studied more carefully by a human. AI and predictive analytics. So disease risk prediction is important here. AI models can analyze patient data, including genetics, lifestyle, medical history, and predict the likelihood of developing conditions such as diabetes, cardiovascular disease, and cancer. Hospital resource management. Excuse me. Predictive analytics helps forecast patient admission rates and resource needs, optimizing staff allocations, bed management, and supply chains, all crucial to streamlining the workflow in a hospital, ensuring adequate resources are present where and when they're needed, and that patients are treated efficiently and cost effectively. Treatment outcome forecasting. AI can evaluate patient-specific factors to predict effectiveness of treatments, enabling personalized care plans and reducing trial and error approaches in therapy. Personalized medicine is definitely the vision for the future, where it's not a one-size-fits-all, but it is tailored to the specific patient at the specific time and location where they're being treated. We touched on this before, AI and natural language processing, which uses voice inputs. It's simple listening mode in the background instead of having to type and click. The frustrating experience of a patient speaking to a doctor who has their back to you while they're typing on a computer. Now the patient can face the doctor can put full attention on the patient, and the computer system is listening and documenting as they speak. These applications can capture the provider's voice, transcribe it in real time, populate workflows based on simple prompts, voice prompts, and also synthesize and translate trusted provider's voice into dozens of different languages for non-English speakers. This is more present in some of the registration, prescription, and other online systems, but it's an interesting possibility where they can actually synthesize from the original voice of the physician, who may be speaking in some language such as English. They can synthesize the voice into any one of dozens of others. Sounds like that physician is fluent in French, Spanish, Tagalog, whatever the language is, so that when the patient is calling in, they're hearing their own native language and can respond. Of course, with such technologies, trust and privacy issues need to be addressed, and this is a whole area of legal development, understanding, and creation of regulations, guidelines, standards, etc., when you have this kind of capability available. Personalized medicine. As we mentioned, AI can improve diagnostic accuracy and predict disease, identify optimal therapies, and most prevalent in advanced diagnostics, genomics, and drug development, where it tailors treatments based on individual patient data. Companies and research institutions are leveraging AI to design precision therapies, analyze the genome, and predict patient responses to medications. AI use is still evolving due to such challenges as data privacy, regulatory compliance, and integration into existing clinical workflows. So while promising, widespread implementation is still in early to mid stages for personalized medicine in most parts of the world. A couple of risks I'd like to highlight in terms of AI in healthcare. One is in clinical decision support. I've got some references here on the left of where I pulled this from. But AI-driven systems provide evidence-based recommendations. They flag drug interactions and optimize medication dosage. It's intended to enhance patient safety and reduce medical errors, but there are thorny issues around medical malpractice liability. Current laws provide that a provider must be the final decision maker and be liable for any malpractice claims in the treatment and diagnosis of patients. And however, recent tests indicate that human providers can be, actually this is incorrect, can be outperformed by AI in primary care. I'll cite a reference from the New York Times at the end. As AI advances, however, the argument will be made that the AI system, quote, knows more, unquote, than the provider treating the patient, because it's constantly scouring the web, accessing, filtering, consolidating new studies, new information into its memory bank, whereas the busy provider has no time to keep up with all the latest research. And it's often said that within 8 years of leaving medical school, the doctor's knowledge is way out of date compared to what's currently available. So if that's the case, and the AI system is recommending a different treatment or a different diagnosis, and the provider accepts that, who is liable legally if there's a mistake? So currently, case law is unclear, and patient claims will flounder trying to pin liability on the appropriate party. So we can expect a lot of new legislation and regulations to provide adequate guardrails in this area. Patient 2, or risk 2, is patient privacy and data protection, a problem in all sectors of society, but particularly this is an acute problem in healthcare. When I was on the board of a health IT company, our CIO would regularly report to the board that he was literally dealing with millions of attacks per day on their system. And this was not a globally known, it was a well-known company, but not global by any means. And you can imagine what the big companies are dealing with. So you have online data, patient records that are inside the organization and also outside the organization being transferred from one organization to another using trusted networks. And these data stores increase exponentially in quantity and quality with AI. Much more personalized, much more precise, much more sensitive data is now available in these online records. However, the thing to keep in mind is that health data, which is highly personal, highly sensitive, once breached, is irretrievable. Unlike financial, where you can be made whole again, you can recover the money, it can be put back in your account. Once your personal health data has been breached and is out there on the internet, you can't do anything to get it back again. You can't unknow what's already been known. So of course, this leads to huge penalties and reputational loss for all organizations in case of any breaches. And of course, you have now the issue of ransomware, which can extract huge financial costs and bring organizations operating on thin margins to their knees overnight just by extracting this kind of financial penalty and in order to protect this data. So there are now many certifications out there which providers who are purchasing these systems will insist on. GDPR, which is a European standard, quite a stringent one. SOC 2, it's another very popular and table stakes standard that has to be achieved by all companies that are playing in this space if they expect to have a market for their products. However, we should also understand that there are global variations in these standards for privacy and security. So again, if a company hopes to go global with their product, they have to comport with a whole patchwork of standards around the world, which are different in countries like Australia, Canada, the UK, Europe, the US, other countries in Latin America, etc., all have different standards. And so each country you enter, you have to comply with their standards before you can market your products. So as far as crystal ball predictions, I actually asked ChatGPT what it thought the future of AI in healthcare was. I wanted to see how it responded. And here's what it predicts. Predicts enhanced interoperability, seamless integration and analysis of diverse data from electronic health records, wearables, and other sources, creating a connected and efficient healthcare ecosystem. Number 2, real-time clinical decision support, providing clinicians with instant evidence-based recommendations, improving diagnostic accuracy and treatment outcomes. 3, predictive and preventive care, shifting healthcare from being reactive to proactive by identifying at-risk patients and suggesting early interventions to prevent diseases. Personalized patient engagement, improve patient communication and adherence through customized education, reminders, and virtual health assistance. Number 5, ethical and secure data utilization. Privacy-preserving AI will allow secure and ethical use of sensitive health data, fostering trust and expanding AI applications. And it says that as AI continues to evolve, it will play a pivotal role in making healthcare more precise, efficient, and accessible. So it has a very rosy future picture for itself. We'll see how long it takes for all of these things to be achieved and what the stumbling blocks are along the way. I mentioned earlier that there was a New York Times article, this was a year or so ago. A small study was done that showed that ChatGPT actually outdid human physicians when assessing medical case histories, even when those doctors were using a chatbot as part of their workflow. So it shows we're getting to that point today where, we have to really figure out who's responsible here, who's holding the steering wheel in treating our patients, and who's liable in case they make a mistake. That's what I have for you today. I don't know if there are any questions. We have a couple minutes, so I'll stop here.
Thank you very much. And thank you for Blair Butterfield for great insights on the what technology is coming from and what it became. And I would like to just comment that, I'm much more optimistic about AI and what's going to bring it to humanity overall. I loved your example of AI in diagnostics, especially imaging perspective. Interesting statistics that I've seen. Initially, that was thought to be the radiologists will be the first impacted, that they're going to be losing their job because AI is doing much better diagnostics. It turned out to be that now the medical system uses imaging much more because they can see much more details, etc. There's actually a huge demand of radiologists out there, and they're short on number of people who can do the radiology. And as you were saying it as well, one of the biggest challenges is when you're a standard, like you just got a flu or you got a textbook example of an issue, AI is amazing, but when there's an exception, when there's something abnormal that we don't have a data on it yet, I think that's when the doctors and the medical professionals is going to play an amazing role. And that's going to allow to increase the effectiveness of the healthcare, especially when you're doing it individualized healthcare, not just generalized, because that's what, unfortunately, previously in the schools is been taught that, this is what you get when you get a breast cancer. This is what you do when you get this. But individuals may have complete different things, and AI will allow us to be able to concentrate on that individuality and look for cure much faster than what it was. And thank you for the insights. And what is your last thing that, if a healthcare-based company wants to utilize AI, other than that, you mentioned very clearly about cybersecurity, from ransomware to data breach. What is ethically you think a company needs to be worried about AI?
Well, I think, it's not too different in healthcare than any other industry, which is to what extent do you need real human interaction in order for healthcare to be trusted and accepted and utilized by patients who are probably lower on the learning curve than the organization that's applying the AI. So you want to bring them along, hold their hand through the process. So you can't just sort of jump completely into AI and say, it will do everything. And of course, we know that it's like any new technology, it has some bugs to be worked out. That process will occur through interaction between the patients and the provider organization over time. So I think patience is important. I think openness to feedback is important. And I think that education for patients and providers is key for it. So those would be just a few common sense recommendations I would make.
Thank you very much. Really appreciate your session, and looking forward, and I'll follow you on the LinkedIn to be able to get more insights from your postings.
Thank you so much. Thank you.
Next is we have a predictive care AI-powered is Dr. Amit Sawant. And this is a very exciting area because this is what actually becoming an important part of the overall healthcare system. It's great when you get not feeling good and you diagnose with something that you go for a doctor. But everybody knows and understands now that it's much better to do preventative care, which allows you to be much more efficient and much more healthier, personal level. Plus, it actually overall healthcare costs reduce significantly when you do preventative care. I would like to welcome Dr. Amit Sawant. Hi, how are you?
Hey, thank you, Murat. Appreciate it. Appreciate the introduction. Glad to be here. Can you hear me okay? Can you see my slides?
And we'll talk afterwards in the end of the session.
Awesome. Can you hear me okay? Can you see my slides?
And I can see the slides as well. It looks really good.
Awesome. Okay. Hello, everyone. Very excited to be here at the Global HealthTech Summit. I can't believe this is my 5th year speaking at this summit. Today, I want to talk about a paradigm shift that is reshaping our industry, moving from reactive sick care to proactive AI-driven health management. We'll explore why this shift is necessary and how technology is making it possible. Here's our roadmap for the next 25 minutes or so. We'll start by defining the imperative and why we must change. Then we'll look at the operational redesign that is required. We'll get into the specific AI technologies that are enabling this, then the business case for sustainability, and finally, a practical strategy for implementing this. The predictive sick care imperative. We have to be honest about the state of our healthcare industry today. It's all about sick care. We wait for a crisis, whether it's a heart attack, a fall, a diabetic coma, and then we intervene and spring into action with expensive acute resources. Now, this model is economically unsafe, unsustainable, and physically exhausting for our healthcare providers. The data on preventable hospital readmissions alone tells us we are missing the warning signs to intervene earlier before it gets to a very drastic situation for the patient. So underlying this clinical need is a financial reality. We are moving from fee for service, where volume is king, to value-based care, where outcomes dictate revenue. The money really needs to follow the outcomes. In the old model, a hospital bed filled was revenue. In the new model, in the value-based care, a hospital bed filled prevents a penalty. Now, this really aligns the financial incentives with patient well-being. And that's what we should be striving towards and moving towards. And this isn't just theory. Early adopters of predictive models are seeing massive gains. Look at these numbers. A 30% drop in hospital readmissions isn't just a number. That's thousands of patients sleeping peacefully in their own beds at home instead of in a hospital ward. Operational costs drop as we stop putting out fires and start preventing sparks. How do we actually do this? It starts with redesigning the fundamental delivery of care. We need to move from checking on a patient once in a few months, whether that's 3 months or 6 months, to truly understanding their health every single day. Here's the framework that potentially can deliver on that. It relies on 3 pillars. First is aggregation. We need all the data, and not just the clinical notes, but the real world continuous data that we can collect through various wearables, such as your Apple Watches, your Fitbits, your Google Pixel watches, your Aura rings, and so on. Then second is the analysis, AI that can find the signal in the noise. And third, and not the least, is action. Data without action is just overhead. We need workflows that trigger interventions automatically at the right time so that the patient can be taken care of. Visually, the difference is stark, right? Going from traditional model to the predictive value-based model. On the left, we have the traditional calendar-based care, whereby you always hear this, patient, hello, see you in 6 months. Well, truly a lot can happen in 6 months, right? And then on the right, we have continuous predictive value-based model. Now here, you can consider AI as the watchdog that is monitoring 24/7, 365 days a year So the human care team can intervene only when a deviation occurs across the baseline of that particular patient. Let's walk through a patient journey. Imagine Mrs. Jones. She's wearing a smart band, let's say an Apple Watch. Step one, it monitors her gait. Step two, the AI notices she's walking slower and her heart rate variability has changed. Step three, an alert goes to her nurse manager, her caretaker. Step four, the nurse calls her, adjusts her medication, and schedules a home visit. In this journey, no ambulance, no ER trip. So let that sink in. Now that is truly how we want the workflow to be. That's a game changer. Now let's look under the hood. What technology is actually powering this risk prediction? It starts with the architecture, the data. The data is the backbone. We are pulling data from everywhere, from different sources, EMRs, EHRs, claims data. You have the IoT devices, the sensor data coming in from these Apple Watches, your Aura rings, and so on. So all of this data is messy. The key innovation here is the normalization layer. Typically in healthcare, we use FHIR standards that allows our AI engine to understand that BP in one system is blood pressure in another. So that aggregation of data, that normalization, that standardization, that's a really game changer. And that provides as the input to all of the AI that can be applied on top of that data. The output of this is an early warning system. Imagine a dashboard that doesn't just show you who was sick yesterday, but who will be sick tomorrow. Now, this allows care managers to stratify their population. Now, let that sink in. Now, that's a big game changer, right? The care manager wakes up in the morning and knows exactly which 5 patients he or she needs to call today to prevent a hospitalization next week. Now, this results in greater job satisfaction for these care managers and also results in a better outcome for the patients. Today, the sensors are getting smaller, cheaper, and more accurate. We have clinical grade wearables, ambient sensors that can detect a fall without a camera, and apps that patients can go onto and report their own symptoms. Now, this ecosystem creates a 360-degree view of the patient's life outside of the clinic, outside of the hospital. And when you provide that data to a healthcare provider, to the clinicians, to the physicians, the caregivers, this additional context, along with the episodic readings that the clinic or the hospital has, can provide such rich information to derive their analysis and whatever next steps that they can come up with. So that is super powerful. Now let's bring all of this together and look at it from the lens of a real world example. My last role with a health tech company called Somatix, where I worked for about 4 years, we built an AI powered platform that is highly scalable and cloud enabled. We built a remote patient monitoring platform that consists of a smart band, a caregiver dashboard, and a couple of apps for the user, for the caretaker, and also for the family members. We do a lot more with wearable technology than anyone else. We track activities of daily living, and here's a list of all of the things that we can monitor, along with the real-time alerts and providing clinical insights such as insufficient sleep, dehydration that is trending away from the baseline. We also do predictive analytics, that is fall risk, pressure sore risk, and UTI risk. And we do all of this passively by monitoring a patient 24/7 through a wearable device. Like, we built our own device. We could also use Apple Watch or some of the other commercially available smart bands. So here, there is no need for external hardware. It works indoors as well as outdoors. And we used our patented gesture-based detection technology that is based on your wrist movements. We can identify whether somebody is drinking, somebody is smoking, or taking a pill, just purely based on your gestures, your wrist movements. Now, I call this as the so what slide. Our technology has been proven in the market. Here are some real world results from a senior living facility. We did a 6-month study with and without Somatix's SafeBand technology. And here it shows that the numbers speak for themselves. We helped improve the quality metrics, reduce falls, and also reduce UTIs. And we also, at the same time, we also made sure that the engagement was very high and the adherence, that is the patients wearing the bands, was really high. So we can collect all of this continuous stream of data. We must address the elephant in the room, ethics. AI in healthcare cannot be a black box. We prioritize algorithmic fairness to ensure no demographic is left behind. Privacy is absolutely non-negotiable. And importantly, this is human in the loop AI. The machine suggests, the clinician decides. It needs to be a decision support system. And a couple of the previous speakers also talked about this. The results speak for themselves. In heart failure, we have seen ER visits drop by over a third. In senior living, simply detecting a change in gait, walking speed, or balance allowed staff to intervene before a fall happened, reducing injuries by up to 60%. Now, these are lives saved. That is moving from reactive to proactive. Finally, let's talk about the business case. Prevention is often seen as a cost center, but in a value-based world, it is the ultimate profit center. Now, here's the cost curve that compares the reactive in red versus predictive in the green. Look at the red line. That's the status quo. Costs spiral as chronic conditions worsen. The green line is the predictive path. Yes, there is upfront cost in terms of investing and implementing in the technology, but by avoiding the massive spikes of ICU visits and emergency surgeries, we flatten that cost curve over time. You cannot manage what you don't measure. We are moving from measuring bed occupancy to measuring preventable events avoided. Now, I understand this is a harder metric to capture, but it's the one that matters the most. And ideally, we should target about 20 to 30% reduction in these adverse events. let's discuss how you go about implementing your predictive care strategy. For the leaders in this room, my advice is to start small, but think big. And don't try to boil the ocean, and that too not all at once. Pick a high-risk cohort, like your CHF or COPD patients, and implement a small pilot. Prove that the return on investment is there, and then scale. And remember, the cultural shift is going to be the harder challenge than the technical one. And now, finally, I would like to wrap up. My message is simple. The shift to predictive care is imperative. We must move from reactive sick care to continuous health management, to the value-based model. Leverage AI. It is the only scalable tool to monitor data in real time and prevent adverse events even before they occur. Now, this approach will drive ROI by improving patient outcomes and significantly reduce costly hospital readmissions. I challenge you with two immediate next steps. The first one is audit data readiness within the next 30 days. You cannot build a predictive model, AI/ML model, maybe let's say using large language models on fragmented data. You need to normalize the data, you need to standardize the data. Like your data needs to be in that state where AI can be applied on top of that. Then the second step, I would say, is launch a pilot. Launch a pilot program for your highest risk cohort. As I said earlier, either CHF or COPD patients. And then prove that the ROI is there internally, and then look to scale. I'll leave you with this. Predictive care is not just a tech upgrade, it's a moral imperative. We have the tools to save lives and make our system sustainable. Let's use them. Thank you. I'm very grateful to Glorium Technologies for once again inviting me to be a keynote speaker at this summit. It's a great forum, and I'm always excited to be here. And here are my contact details. Feel free to reach out. Now, I'm happy to take any questions.
Hi, Dr. Sawant. It's great to hear you again. And I've been following you several years on this. And this is great because you do have not only, specialized on the healthcare, etc., but you have a strong business background as well. And that helps a lot to be able to analyze, because one of the biggest challenges in the healthcare systems is the cost of treatments and cost of overall healthcare system. And as I mentioned, I'm one of the also beneficiary of the healthcare system, which is I'm really start seeing the big value of the preventative care. I got diagnosed with multiple myeloma several years ago, but I find out that being ahead of the information and being able to get the signs advanced and start doing the preventative care, even the specific cancer that I have nobody knows the reason for it yet. But because I've been doing a good health for the rest of my body, I've been very lucky to be able to treat it, and potentially my oncologists start calling it a cure, which is I'm very glad to hear that I'm cancer free. But in that sense, it's how do you see the shift is going to happen from reactive care, which is a kind of a emergency room, kind of you got sick, then you go in there and do it, to preventative care from culturally. How do you see that needs to happen as well?
Yeah, I think I'll piggyback on a couple of the previous speakers who also talked that, who also talked about the fact that our healthcare industry, and especially the C-suite leaders, really need to take it upon themselves to drive this cultural shift. The data is showing that there are cost benefits to be had. There is a financial business case for moving from reactive to proactive. I know the previous speaker also talked about prescriptive medication. All of this data can result in that, and that itself can drive towards better treatments, better outcomes for the patients, and also would make a financial sense, both from a patient perspective as well as from the clinics and the hospitals' perspective. So the cultural shift needs to happen at the top. The data is there to show the business case and the use cases.
So in that case, do you see like things like, individual, as simple as iWatches and personal trackers like I have on my wrist, do you see those to be a kind of a start of preventative care, because it's constantly monitoring your health with limited amount of data at the moment, but I'm sure it's going to increase. I mean, we are seeing the new insulin patches that is constantly monitoring your sugar levels and things like that. So do you see that part of the industry is growing from individual personal wearing devices type perspective?
Oh, absolutely. Just even if you were to just look at the last decade or two, where the use of these wearable devices, whether it's like your Apple Watches, your Whoop bands, or your Oura rings, has drastically increased. And in fact, you can even call it as a clinic on the wrist. Yeah. For these Apple Watches, where a lot, as I talked in my presentation as well, that the sensors are getting smaller and smaller, and also the cost is decreasing, the accuracy is increasing. So it is becoming even more clinical grade. It's not just a good feature to have, but there is clinical value towards that. And also the adoption from healthcare use cases is drastically increasing over the last few years. So that's a very good shift that I am seeing, that it is not just good to wear the bands, but also just imagine this continuous stream of data that you're getting from these wearables. And if it can be ported onto towards a clinician or a caregiver, the amount of additional context that it provides about a person's health, rather than just the episodic readings when a patient goes and visits their caregiver or their doctor, let's say maybe once every 3 months or something of that sort. If on top of that, if you add this continuous stream of data, the context about that patient is super valuable in order for these clinicians to intervene and make the right decisions for their patients. So it not only increases their decision-making capability, but also results in better outcomes for patients, and thereby driving that shift from reactive to proactive.
Yeah. Also, I think specialized devices, as you're mentioning, not only consumer type of stuff, it actually makes an individual medications and reduce the amount of that is being utilized on you. I mean, I grew up with a parent that was diabetic for a long time, and he was one of the most a good patient, in the sense that follow his diet and etc. But he measured twice a day his insulin level and make the injections based on that. Well, it would have been much more different if he could just track it all day long and be able to adapt to it. And I would believe that he would have been using much less if he did that instead of doing it like twice a day. That kind of data information is becoming more and more important.
When you have these, when
yes.
you have these episodic readings, right?
Yes.
So it is at that point in time readings. Whereas, let's say during, now to your example, if that's data throughout the day, maybe a peak happened at a certain point. But if you're just looking at these point in time readings, you are missing out on that peak. And that's a valuable data point to have to intervene and make the right decision for the patient.
And that's great. And thank you very much for great insights. I think it's great to see from a business perspective how the healthcare organization is going to look at it, value of predictive healthcare. And thank you for the insights, and looking forward to follow you on the LinkedIn and to be able to get much more insights.
Absolutely. Well, thank you very much. Take care.
Thank you very much, Dr. Sawant. Hi, our next speaker is David Yang. I'm very excited. He is one of those people who's a serial startup business in the healthcare and different areas. But he is going to be talking about in healthcare industry, virtual or AI specific employees that you're going to have. And David is a TEDx speaker, and he has a very interesting background from philosophy, PhD to AI and healthcare and different kind of areas. And I would like to welcome David Yang.
Hello.
Hi, David. How are you?
Good. It's my pleasure.
Yeah, it's been amazing to look at your background and amount of different startups that you started. And I'm very excited about the topic that you're going to talk about, the AI employees in healthcare, and looking forward to the topic.
Thank you very much. Yes, my name is David Yang. I'm a PhD in AI. I started 13 companies, and we have been deploying our AI technologies for many years, more than 30 years. And more than 50 million people are using our technologies. And today, it will be my pleasure to share insights which we got based on our latest work and latest experience. Specifically, we will talk not about whole AI. We will talk about a specific area which is called AI agents, and even more specifically, agents which are called employees, AI employees. We also will talk about which healthcare facilities are ready for AI employees, AI agents, which non-clinical frontline roles can be considered for them, and three biggest mistakes when hiring AI employees in healthcare. Some of you, and I don't know if it's a two-way communication, if we are capable of getting answers from our audience. In case yes, please share your information. Have you already tried using AI receptionists and AI employees? If yes, are you kind of using already right now, or just tried and failed? Or otherwise, if you considered to hiring AI employees in nearest 3 months. So please share that information. In a couple of words about your size of organization, number of locations, and type of services, medical services. Also, the last element which I will talk about is why healthcare organizations are considering AI employees Is it to save costs or actually get more revenue? And we'll answer to this question. Spoiler, new revenue from new patients a lot. Okay, before we go into the specifically healthcare, you might be interested about other industries as well. OpenAI revealed recently their study of 44 jobs which will be soon replaced by AI, according to this study. And you can see I highlighted with bold those AI agents which relate those jobs which are related with the front line. So basically, AI receptionists and AI sales type of agents are not applicable only for healthcare, but also for many other industries like hospitality, real estate, finance, etc. Industries. Industries are not only, again, healthcare, dental, medical, but also beauty, wellness, fitness, automotive, etc. Now, let's talk about specifically healthcare facilities already for AI agents, the frontline AI agents. Our current experience with speaking with hundreds of business owners and related to healthcare shows those items: outpatient care, hospitals, urgent care centers, wellness centers, health screening centers, physical therapy clinics, general dentistry clinics, orthodontics, oral surgery. Those organizations are currently the fastest growing in healthcare related to AI receptionists, which non-clinical frontlines. And what specific roles and job position: receptionist, front desk coordinator, patient service representative, scheduler, appointment coordinator, medical billing coding clerk, and healthcare call center agent. So I guess the heading of this slide is not related, but this is the most important I wanted to share. These 5 job positions in healthcare, which are the fastest growing currently in terms of adoption of AI receptionist, AI adoption. Size is huge, and finally, you might apply this information to yourself, whether you feel that your business is ready to start hiring AI receptionists, AI employees. Either you have a call center, or you're a single location clinic, or you're multi-location, or you are actually solopreneur in individual provider. What AI employees actually can do? They can do a lot of elements which typically human receptionists have been doing and currently still doing: answer calls, respond to text messages, sell products and services, set appointments. Why it's important? The study shows that, in fact, 62% of all inbound calls on average in the US remain unanswered. This study was conducted across 85 businesses during 30 days. the researchers made thousands of calls, and only 37.8% actually get immediate answer. 24.3% no response at all, and 37.8% the voicemail, which in many cases never has been returned. So this is a huge problem for the businesses. I know that in medical organizations, specifically in orthodontics, for example, it's the unanswered rate is much lower. And the reason is simple. The leads we're losing if we're not answering call for in 2 rings is enormous. New patient brings from $4,000 to $5,000 lifetime value in orthodontics. In general dentistry, lifetime value of a new patient is reported between $500 and $1,500. So basically, one new patient is spending their funds many times during their lifetime cycle. So missed calls is a big problem, and what benefits do we have by addressing the missed calls problem? Obviously, revenue, customer retention, patient retention, new revenue. Where this new revenue comes from? From non-working hours, when our human receptionists and even dedicated call centers do not respond at all. And in different businesses, this number can vary, but this slide is a real fact. Now shows $23,000 per location per month in additional new patient bookings during non-working hours only. Also, we're losing revenue during peak hours, rush hours, when we have 5 receptionists, or let's say 3 receptionists. 3 receptionists cannot take 6 parallel calls. And this is exactly what happens during rush hours when we have live patients walking in and several calls are happening simultaneously. How do AI receptionists work? And we will listen to an actual call in a minute. They can respond like humans 24/7 without any breaks and take unlimited parallel calls during rush hours. They can check available slots in PMS systems, patient management systems. They can book appointments and schedule. They can send text messages and send information via text, including links for self-booking in some cases. They also can make outbound calls during some deals in the seasonal offerings. They can do mass at scale outbound calls and outbound SMSs to attract the base called patient base, which never got treatment. They can do lead nurturing, reminding about upcoming appointment and calling after the appointment if, for example, we do some surgery or some other paid procedures. If the person visited and considering, so agent can do check-in calls asking, so have you decided or not, and to increase the conversion to revenue, to booking. So let's listen to an actual conversation, and let's hear how emotional they are. New generation, third generation technology, which we are representing, actually can smile, can whisper, and can express sympathy. Let's listen.
Thank you for choosing Image Orthodontics Pacific Heights. This is Emmy, your AI receptionist. Puedes hablar en español conmigo. How can I make you smile today?
Hi, I need Invisalign, please.
Sure. May I confirm if you're a new patient or reaching out for the first time?
I'm reaching out for the first time, but the problem is that I'm scared of doctors.
I understand that you're feeling a bit scared, and we completely understand. We'll make sure everything is comfortable for you here. Would you like me to help you schedule an appointment for Invisalign?
Could we do the entire procedure over Zoom call? I'm just kidding.
That's a funny idea. While we can't do the entire procedure over Zoom, we'd be happy to schedule a consultation for you here. Would you like to do that?
Yes.
Great. And would you like to schedule this appointment for yourself or for your child?
This is for me.
Wonderful. And do you have a particular day or time in mind for your consultation?
Could we do tomorrow, early afternoon, please?
Absolutely. Just to confirm, you mean tomorrow, Tuesday, May 27th in the early afternoon?
Yes.
Give me a moment to check available slots. I'll get back to you shortly. I found a few openings for tomorrow in the early afternoon.
So you can feel this completely new energy and emotional conversation, and in tech where it works 24/7, scheduling calls, checking available slots. Just a couple of by the way, if we have any feedback, I see chat is empty. Messages from audience will display here. So I wonder if any of the participants is willing to share information and some feedback about the quality of conversation and any concerns, because it's a very, very important transformation, digital transformation, which is happening right now in thousands and thousands. Medical centers and healthcare organizations are currently start deploying AI agents and AI receptionists. So please share your
Yeah, there's in the beginning you asked a couple of questions, so not yet the answer about the AI employees, not yet, but we are testing a couple of AI receptionist tools for call routing and basic frequently asked questions. Still unsure if they are fully implemented. Another person says, yes, we use an AI receptionist for after-hour calls and appointment scheduling. It's been a game changer for reducing missed calls. Last is we are on. Another person is saying we are only experimenting with AI for website chat, nothing for the phone reception yet. Curious to learn how others are using it. Another person is no, but leadership is pushing us to evaluate AI options for front desk support, looking for something that integrates with CRM. And last but not least is we tried an AI receptionist 6 months ago, but paused it. Customers liked the quick responses, but we needed better customization.
I see. Very, very helpful and exactly aligned with what we have. So some people tried and decided to pause because the quality of conversation 6 months ago and 1 year ago is completely dramatically different from current third generation voices, which have low latency, high resistance across for the background noises, and they are integrated with the CRMs. So if you have more questions in the end of this presentation, you will have the QR code, so you will be able to ask more questions offline. And just a couple of words again, AI's big agents are overall technologies which can, remember and have some goals. But AI employees and specifically AI receptionists are the elite class of AI agents, which are connected to CRMs, which can respond emails, respond phone calls, live chat, so they can cover um, all channels. It's not only voice, actually. Someone mentioned, yes, that's right. It's also web chat. It's also Instagram, TikTok. If you are providing medical services, you are generating your new patient leads from many social media, many channels. And if you're not able to answer direct messages on Instagram or TikTok right away in a second, you are losing your new patient. New patient is impatient. They don't wait a lot. When they call, they only wait for 2 rings. If you are forcing them to wait 3 rings, 15 seconds, 50% of new patients already dropping the call and calling the competitors. If you are forcing them to wait 4 rings, it means 20 seconds, 90% of new patients are believe that the phone is wrong, or the business is closed, and they calling to the competitors. So it's very important, the speed of reaction. If you put them on a voicemail and you're trying to return the call, you know that only 90% will never actually reply. And this is the case study on one of our customers, Image Orthodontics. They deployed the technology, AI receptionist technology, this year. I mean, actually, a year ago. And January, February, March, they decided to make audit how many calls actually have been received and how many new patients converted to treatment. And interestingly, that you see 10,865 calls AI handled during 3 months, and 322 new patients, not only attributed to AI only, but actually these physical people actually paid and started treatment. And they already paid almost $500,000 during these 3 months in additional revenue. How this technology worked there? It is still obviously working. Non-working hours first, when human are losing calls, and second, during working hours, overflow. It means human first, AI second. Human receptionists are trying to get the call in the beginning. If they fail to take the call in 2 rings, 10 seconds, the inbound call automatically is being redirected to the AI receptionist. And AI receptionist captures and rescues that missed calls. So 10,000 plus calls during 3 months have been rescued. It's humans took more, but these all calls are missed, 40% actually. So and out of that missed calls, 322 new patients not only have been booked, but also arrived, attended the appointment, and started treatment. There is another case study from other industry, just in case you guys, I know some participants are not only running healthcare business, but also running other businesses, and similar AI receptionists, omni-channel, are working there. I have 8 minutes left, so I will deliver what I also promised: mistakes when implementing AI receptionists. First mistake we learned, and we're running thousands and thousands of organizations. I want everything at once. That request from business owners, we got a lot. We've got very often, and it is very much it is not the most efficient way to introduce new technologies. Our experience suggests that we need to start with low-hanging fruits. What? Everything at once. Now, the business owners wants not only take existing new patients and schedule calls, but they also want to immediately treat existing patients and make rescheduling and make cancellations and changes in appointments. That treating existing patients is a very complex task with legacy PMS systems. Many PMS systems, legacy PMS systems, do not have API, which will allow to do it automatically. So it's still possible. There are ways to still work with AI to work with the legacy systems, but it will take time. It may take time like a month or 6 weeks to implement. We recommend to sometimes 3 months. We have situations when that integration took 3 months. We recommend to start with the most rewarding and most important element, new patients. And new patient workflows can be implemented in days. Technically, with some PMS systems, with literally hours. For small location, single location business, it could be hours to implement. For multi-location business and with a call center, typically it takes about a week to several days to implement and make interviews with current supervisors who are dealing with call center standards and standard conversational scripts. So all that conversational scripts should be added to the brains of AI, and then several days of testing. So in about a week, you can start non-working hours first tries. So it will work during non-working hours for several days. Anyway, that calls have been lost already, so it has a low barrier to enter. Then we listen together with a customer and we see some information which potentially is missing. We add this missing information, we do it again, and after that we deploy working hours after humans. So human first, AI second. So after 2 rings, the calls redirected to humans. So low-hanging fruits, and this is number one. Number second problem, I won't launch until it's perfect. And AI is a non-deterministic technology. Even now, when we have 3rd generation and they work very, very good, still there are situations when AI might be confused with kids playing in the background or something. So our experience suggests that we need to start with something. It's like trying to learn swimming in the pool without water. You can't do that. You should put water, you should start swimming, and then you will learn. So put your AI technology after hours first. Again, you already missed this call, so put it for 2 days or 1 night, and see like 10 calls, 5 calls, 15 calls, capture, listen, and you will see what if some changes, improvements will be needed, and then you will step by step. So like humans, also humans are not perfect. Humans never perfect. AI also never perfect. It's a path. So and third mistake, I'm afraid to launch because I'm not sure. Yeah, this is kind of general objection which we see from some businesses when say, yeah, I know I'm losing revenue, I know I'm losing new patients, but kind of I'm afraid. Guys, competitors already doing that. Your competitors already capturing all new patients. If you wait after 2nd ring, your new patients go to your competitors. You donate them. We believe, and our experience shows, it will be okay. You start with non-working hours, human first, AI second, and you will see how much tens of $1,000s per month per location. For 15 location organization, you are thinking about $1 million, $2 million new revenue, new patients revenue per year. Okay, guys. I just wanted to kind of give you a couple of minutes. If you still have questions, please ask. This is Ray Kurzweil. We're a very famous scientist who coined this singularity term. We discussed this, and also I discussed AI consciousness with His Holiness Dalai Lama when I visited his residence Dharamsala. Anyway, this is my email, david@newo.ai, newer like new world, and david@newo.ai. Now, I'm happy. I'm a co-founder of this company, PhD in AI. I will be happy to answer any questions offline. And if we have still 1 minute and one question, no?
Sure. So thank you very much, David. This was very insightful, and looking at the different AI options from employee perspective, and what's the value that it brings in. And I like it when you say that you've been doing AI for many years. It's as an IT person of over 40 years in the industry, people goes, "Oh, AI is so exciting, it's new," and I'm like, "Not really. It's been there for a long time. It's just." Now it's available to much more larger audience, and it's great to see that actually human type of interactions. And I like your concept again. It's a lot of people makes that mistakes that what you see or you tried 6 months ago is very different than what's happening today. This technology is going forward very fast. So I would like to encourage people to get in touch through his email or LinkedIn or similar type of platforms with David for any questions, any experimentations you would like to have with Nuvo.ai.
And I forgot to say I was told to say, and I forgot.
Sure.
For the participants of Global HealthTech Summit, we have an enormous actually offering. We for you guys, we decided to extend our Black Friday offering 4 months for free. By the way, so please, if you will write to me and put in the subject line. I cannot read all emails. I'm sorry, but if you will put in your subject line Global HealthTech Summit, so I will see that immediately. And I promise you, we will give you 4 months for free, cancellation free, risk free, only for you guys. So you will be able to try without
That's
any.
amazing.
Yeah.
That's very, very good. Thank you very much, David. And
Thank
4
you.
months is a great way to experiment and adapt to such a technology. Thank you, David. And
Thank you.
I hope people take advantage of this offering.
Thank you. Thank you. Bye.
Bye. Thank you, everyone. And we are going to give a 10-minute break. And in 10 past, we're going to start. And there's a lot of interesting stuff like language of biology we're going to talk about, strong culture, how to create it. And then we're going to talk about transforming the patient care. And last but not least, we're going to talk about the real world impact of these technologies. So I'm looking forward to see you in 10 minutes. And we will make sure that all the speakers are aligned, and you should be ready with your questions and comments. See you in 10 minutes. Hi, welcome back, everyone. And here's the second part of Glorium Technologies Healthcare Summit. This is a very exciting technologies we already seen. But next speaker is Susan Tosi, CEO of Delphi Diagnostics. She has an incredible background, and she has a very interesting approach to overall AI and healthcare in there. So he's teaching machines to the language of biology, and individual medications is very important part of the discussion. And welcome, Susan.
Thank you, Murad. It's fantastic to be here. Can you hear me okay?
Nice to see you, and welcome, and looking forward to your presentation. Then we'll talk afterwards.
Sounds great. Let me bring up my slides
Sure.
and get started. Can you see these okay?
Everything
Okay.
looking good.
All right, wonderful. It's half the battle. But just by way of reintroduction, Susan Tosi, I'm CEO of Delphi Diagnostics. Our mission is to make cancer less deadly through widely accessible early detection. And that is fundamentally powered by AI. And I'm here to tell you that I believe that genomic-based AI is healthcare's biggest opportunity. It's going to help us not only to find disease at its earliest stages in asymptomatic populations where you can make a difference. Patients have many more options, much higher survival rates. We can transcend the clutter, the complexity, the cost structure of our current healthcare system. And importantly, we can really democratize access to life-saving technologies that can get to every corners of our country and actually even the global population. So with that, let's dive right in. And I thought I would talk a little bit about, one of the biggest diseases challenging mankind is cancer, and that's our focus at Delphi. And the detection of cancer at its earliest stages is like looking for a needle in a haystack. This is before patients actually have any symptoms. And this is a unique challenge that can save, thousands of lives, millions of lives globally. And we can do that now through the access of large-scale genomics sequencing and the power of AI. We're at an inflection point in healthcare AI, and the healthcare industry, one of the largest investors in R&D, is actually at the forefront of applying AI because they see some of these issues on the horizon. They see that we have an aging population, disease prevalence is growing, cost is growing, and now for the first time, the convergence of having the data at our fingertips, the computational infrastructure to actually apply machine learning and more complicated algorithms and do that at a fast turnaround time. And importantly, the clinical need are all converging in place where, AI can really be applied to this problem. And I want to talk to you about why, our approach to actually using the entire biology in the detection of cancer is enabled by all of these transformative changes, and why our approach really is, the secret to finding cancer at its earliest stages in a way that's scalable and very cost effective. So let's talk a little bit about the cancer detection challenge, this needle in a haystack problem where you have to test populations of people who are asymptomatic to find those who have cancer and who you can treat at the earliest stage. Cancer screening is a difficult problem, and we are at the forefront of really focusing on finding cancer at stage 1 or even earlier. This is when patients have the highest survival rates and when therapies can be the most effective, or even surgery can be a curative therapy. The challenge with doing that, and especially doing that with diagnostics that are non-invasive, in our case, a simple blood draw, a blood test, is that cancer is not very, prevalent when you're looking at the bloodstream and cell-free DNA that's shed from tumors. It's at a 0.01% concentration. So you have to have very high sensitivity, very high signal to noise discernment to be able to find cancer at those early stages. And as we know, diagnostic tests, I mean, most of them thankfully come back negative. The 95% of them are negative. It's that few percent, that 5% that you really need to focus on to find disease at its earliest stage. And the implementation of AI and large-scale biological data is how we get there. Traditional methods and kind of diagnostics to date have fallen short because they're typically really relegated to looking at just one biomarker or single genes and single gene mutations. And they really miss the pattern that can be available when you're looking at the entire genomics of the cancer, which tells you a lot more. Yet, the analysis techniques to date have really not, enabled looking at this pattern recognition that's available when you look genome-wide at cancer. And the cost structure of doing genome-wide testing has not been available. And the challenge with many of the diagnostic tests that we have today is if they're imaging based or microscopy based, they require large-scale infrastructure. You have to be close to where that infrastructure is available. In the case of, for instance, lung cancer screening, which is a first focus for us, getting to a low-dose CT scan is, even in the U.S. where there is, large-scale infrastructure, most Americans are like 4 hours away from where they can get a chest scan done. So it's not equally, distributed. And in many places, not just in the US, but globally, you need technicians, radiologists, or in the case of cytogenetics, people who have expertise in microscopy looking for these signals of cancer that are really becoming even more rare to find, and in much of the globe can't be found at all. So how do we transcend that and make it really easy, put the power of the data and the power of AI to use in distributing this in an equitable way, making it cost effective, making it such that it can be deployed at scale in populations? Well, we're at that inflection point where all of this is for the first time becoming really possible. We have a few things that are converging. One is that, the data insights, the massive amount of data that's available to us now through large-scale genome-wide sequencing is at a point, at cost structure, at availability, at a scalability that's never before been possible. And before I was the CEO of Delphi, I spent 12 years at Illumina, the largest kind of provider of genomic sequencing. I ran the product development group there for 9 years. I was chief commercial officer for the last 3 years I was there. And we were really working on making genomic sequencing accessible, available, low cost, globally spread. We were chief commercial officer serving 155 countries with genomic infrastructure. So really the access to genomics is like it's never been before. And the ability to have the computational horsepower at a turnaround time, at a cost structure that can allow us to use sophisticated machine learning and algorithms in a way that like never before is really at the forefront and here for us to use. And then the clinical need has never been more apparent. Our healthcare system, we know the cost structure has been increasing. It's kind of at an untenable point now. We have an aging population where disease prevalence is only going to grow. And, as I mentioned, the accessibility is a barrier to many to be able to access the, latest technology, the best, standard of care. And we have to change that, and we can. And these forces are now converging to help us to do that. And the healthcare system is waking up to the fact that AI is going to help solve a lot of these problems in our healthcare system. In fact, they're not standing still. They're one of the fastest adopters of AI. 27% of healthcare systems now have some kind of domain-specific AI. This is everything from ambient listening tools to pick up on kind of patient interactions in a way that, a very busy primary care doc may not. It's helping them with billing processes. It's helping them with, following up on diagnostic testing of patients. It's helping in surgical robotics. So really, kind of increasing in scale, 7 times increase in 2025 over 2024 in the adoption of AI tools in the healthcare industry, and a tripling of the spend in AI in healthcare. So this is really being seen, AI is being seen as a key driver of how we're going to solve some of these healthcare challenges and actually improve the health of the population. Healthcare is, largest R&D investment, is a sector with the largest R&D investment. And so it stands to reason why, with a large R&D investment, that they would also be on the forefront of adopting AI. And then if we look at the accessibility of the biological information in the way of genomics, it has been moving very fast. In fact, if you haven't been watching how fast genomic sequencing has been evolving, it really is staggering, moving, orders of magnitude faster than Moore's law. And of course, Moore's law is the observation that the microprocessing speed, or the number of microprocessors, is doubling, and the cost is halving, and that's the line at the top. And so that was what powered the computer age, is this incredible scale and cost reduction in access to microprocessing. And if you look at what's been happening in genomics, it's been moving a lot faster. In fact, in 2003, the first human genome was published, and that was, the Human Genome Project. In 2003, it had taken 13 years and $3 billion to sequence the first human genome. And we're now just, nearly 2 decades later, and we have the human genome costs closer to $100 to sequence. It can be done on, equipment that's available, as I mentioned, in 155 countries around the world. So the access, the scalability, and there's been a number of technologies that have come together to make this happen. There's a platform technologies, the lasers and optics and microfluidics, the biochemistry that's continued to improve. And then, the kind of computational horsepower, the bioinformatics algorithms that have helped to process all this data. And all of this kind of convergence of technologies has driven the access to large-scale genomics becoming, available in a way never before. And at Delphi, we've adopted this into our testing. In fact, the first generation of blood-based tests for detection of cancer were relegated to looking at only certain points across the genome of cell-free DNA, typically mutation sites. And for us, we were able to take a much more kind of future-oriented approach using the whole genome, doing genome-wide sequencing of all the cell-free DNA, not just kind of filtered down to a few points. And as such, our ability to derive patterns and signals and this kind of signal to noise of being able to find stage 1 cancer with very high signal to noise is unlike ever before. And that's what we've employed in our methodology at Delphi. And so machine learning has been kind of core to this, and being able to train on this large-scale genomic data has helped us to really discern these patterns that are completely indicative of the early presence of cancer. And cancer at stage 1 is very different than, what you find in stage 3 or stage 4. So you really have to train and have a biobank that has stage 1 cancers that has been trained across asymptomatic populations. You need to be able to train on many different kinds of patterns that, tie to the presence of cancer. And in doing so, you can have a test that really is, very simple from a wet lab or kind of processing of the DNA standpoint. In fact, it's as simple as you can get because we're really just looking at the whole genome. So the assay is very simple. And the deployment is really made through algorithms, deploying algorithms rather than deploying this large-scale wet lab infrastructure. And that really is kind of the secret to how we can get this deployed in a way unlike ever before. And so let's talk about the Delphi approach, and that is making early detection accessible through this use of genomic AI. As I mentioned, the first generation of these liquid biopsy or blood-based tests for the detection of cancer, and they're looking, as I mentioned, at the cell-free DNA that's shed from tumors, and at very early stage. The first generation was looking at panel-based targeted approaches, mutation-based approaches, very high cost because they're very complex assays and very complex readouts to get to the kind of output of that test. And for us, our cost structure is very low. We use low-pass whole genome sequencing. As I mentioned, genome sequencing has, kind of precipitously fallen in cost, which is, fantastic in that we can use kind of the entirety of the biological information. We have one basic assay or one, core wet lab approach, and different tests can be called for different cancers, and even, monitoring of disease response through deploying new algorithms. And we have this continuous learning cycle because we retain all the information from these samples, the whole genome of these samples, and we can go back and retrain on this data as advances are made, more training data is available. So there's this continuous improvement in the test performance and sensitivity. And then, of course, the accessibility of being able to deploy this test really as easy as deploying algorithms is unlike ever before. And so our approach using kind of whole genomes, genome-based testing is, operating on a lot more data. If you're only looking at mutation sites, you're on the left of this scale, where you have like 100 points, 100 known mutations that you can use for detecting cancer. If you're looking at methylation patterns, now you're in kind of the thousands. In our case, we're looking at all the entire feature set across the genome profile. And that, those patterns that we're looking at are now in the millions. We have a lot more data to go on to derive the signal of cancer. The way we describe this is, I liken it to if you are, dropping a rock in a lake or throwing a rock into a lake. If you are looking at exactly, where that rock is, it's like looking for a mutation. You would need to know where it entered the lake. You would need to have to sample the, every depth of water to be able to find exactly where it is. It's that needle in a haystack problem. In our case, we liken it to, we're looking at the signature or the pattern that's resulting from the presence of that cancer, not just a mutation that might be available in one fragment but not another. So we're looking at the ripples emanating from, the entry of that rock. And as such, we have this much larger signal based and can detect cancer at a much earlier stage. And so to describe this further, the way our process works is we do a simple blood draw. We're looking at the cell-free DNA that exists from cancers that is existing in the bloodstream. And as I mentioned in a previous slide, that is a sensitivity challenge, 0.01% presence of cancer DNA at stage 1. So really benefiting from this large signal framework that we've created. We do massively parallel sequencing, whole genome sequencing of that cell-free DNA, so we get all of the biology through the genomic sequencing. And because cancer is a disease of the genome, it's a highly mutated genome that's created, and it replicates and kind of goes unchecked. And so these mutations are everything from alterations of replications, amplifications, deletions, chromosome arms that are gained or lost. I mean, there's this huge pattern of changes that cause this chaotic nature in the cancer DNA and what we use for training our models. And so if you look at, what does this look like, or how does this manifest itself? Here I'm showing a graphic that is, directly out of our publication of our case control L101 study that was published in April of last year in Cancer Discovery. And it's showing this fragmentomics profile, or this fragmentomics score that we calculate based on all of the kind of cancer alterations that I mentioned in a whole genome approach. And on the x-axis, you're looking across the autosome, or the 22 chromosome pairs. We're looking for a signal of cancer, in this case, lung cancer. And you can see that, on the top line, you have someone who doesn't have cancer. And so this fragmentation profile, so the combination of all those alterations, is, very small. You have this really tight pattern of fragmentation in a person who doesn't have cancer. In the middle line, you have someone who has a benign lesion. And similarly, although the lesion may, look suspicious on a chest scan, when we look at the fragmentation pattern, when we look at the whole genome of the cell-free DNA, you see that the cancer alterations aren't there. And then the kind of bottom line is someone who has the presence of cancer. And you can see that when you're looking genome-wide, this large signal is really apparent. And of course, we don't just do this by eye. We do this through training our algorithms. And these algorithms have been developed now over more than 100,000 samples. And so we really have this high recognition of these patterns. And as I mentioned, if you were only looking at those 100 points along this line of mutation sites, you may not pick up on this large signal base. So really, this genome-wide approach and the availability of complicated algorithms and machine learning has been core to us having very high stage 1 sensitivity for lung cancer. Our approach, our methodology has been published. We have a number of pivotal peer-reviewed publications. You can see at the top, this is just a sampling of them. So we really are the leaders in this field. We have more than 100 patents that have either been issued or advanced stage of filing. And this is really building on a body of work in looking at cell-free DNA and liquid biopsy that has been a burgeoning field, really at the forefront of impacting cancer survival. And as we look at how can we really benefit from this genome-wide analysis, we're really encouraged by what we're seeing. This genome-wide approach, and hopefully by now you're kind of following along, that this genome-wide approach really is giving this much larger signal context to detect cancer at its earliest stages. Can be applied to many different cancers. Our first product is in lung cancer, and our first clinical trials are in lung cancer. But we have peer-reviewed publications in liver cancer, ovarian cancer, the 7 deadliest cancers. So this is a methodology that can be really applied to the entire kind of cancer continuum. And earlier detection, of course, and better insights is absolutely critical. The fact that these screening tests are annual, we get this now longitudinal signature on patients, so the test can become, ultimately more and more sensitive for that patient, because we now have this pattern recognition for an individual patient. And because it is one wet lab process, because we're using whole genomes, not just mutations that might be specific to one cancer, versus another, we can apply different algorithms to the same core test and be able to, through deployment of new algorithms, enable new indications, new cancers, and of course, monitoring and ultimately MRD applications. This is how simple our test is. This is our lung cancer test, which is on the market as an LDT. We have breakthrough designation with the FDA, and we are advanced in our filings with the FDA, hoping to have our clinical studies all done next year and filing our complete IVD submission by the end of next year. But we do have this LDT on the market. We're generating real-world evidence. It is a simple blood draw, 1 tube of blood. We use the whole genome sequencing method as mentioned, looking at the fragmentation profile. The test report comes back within 2 weeks and tells a patient whether they're very unlikely to have cancer, 99.8% chance that they don't have cancer if they're negative, or if they're positive, they have 5 times more likelihood to find cancer in downstream processes like a chest scan. So we're sending the people who really have the highest risk to get scanned, have biopsies, have surgeries. So we're improving not only getting patients who today for lung cancer screening don't get screened. Although lung cancer screening has been guidelines for more than a decade, 80 to 90% of patients don't get screened today. So hopefully we are capturing, a much higher majority of those patients to get screened, because finding lung cancer at the earliest stages has high as 73 to 95% survival rates at stage 1. These are 10-year survival rates. But when found, as it is typically today in stage 4, the survival rates are in single digits, 5 to 7%. That's why lung cancer is the deadliest cancer. 1 in 5 cancer deaths is from lung cancer. So this simple blood test, we believe can impact that in a major way. And adoption of our test and increasing screening rates can save up to 10,000 lives a year in the US alone. And of course, our ambitions don't stop at making an impact in the US. We want this to be a global test accessible to all. And looking at the real world impact of our test, and we're generating this evidence today. We had first presentation by a health system, Allegheny Health Network at the CHEST conference, showing that we're increasing the uptake of downstream kind of scanning, CT scanning. So we're sending the patients who weren't getting screened downstream to getting their CT scan. We're making better use of the resources of large scale infrastructure like LDCT. By sending the patients at the highest risk to get that testing. We have a financial benefit on the overall healthcare system. We can save billions of dollars to the system by finding cancer early, where treatment is much more effective and lower cost, rather than in the latest stages, improving lifespan by an order of months. And at a very high cost. So, we're kind of moving the needle, moving the kind of trajectory on cancer to a much earlier stage, much higher survival, much lower cost. And of course, we're solving this equity issue in that, this is really the democratization of the most advanced techniques for finding early stage cancer. Because, our test is available anywhere you can get a blood draw. And that is true democratization. And you don't have to be, within a few minutes of a large-scale medical center that has the infrastructure. You can be anywhere that you can get your blood drawn, and we can get you tested. And, we do have ambitions to go beyond lung cancer. Lung cancer, of course, is a very large challenge. 15 million people in the US alone who should be getting screened for lung cancer. As I mentioned, 10,000 lives that can be saved in the US alone by adoption of our test. But, lung cancer, first of all, going beyond the population of just former smokers to people who've never smoked, because we know the incidence of lung cancer in people who've never smoked is increasing. So we'd like to expand the intended use of our lung cancer test. We'd like to add other single cancers. And as I mentioned, we can do that by just adding new algorithms on the same kind of assay. And colorectal cancer, liver cancer, ovarian cancer, going to multi-cancer testing, going to international testing. can get to hundreds of millions of lives. And then, of course, we also, with the same approach and the same assay, different algorithms, we have a monitoring application. This is used by 5 of the top 20 pharmas. We run this, as a service for pharma, and they look at the kind of therapeutic response to treatment, helping to really stratify their drug candidates for those that could be most successful. And the wonderful thing about monitoring is you can really catch monitoring in this way can catch the response. A few cycles of therapy, a few chemotherapy cycles, before any imaging can. So really a huge benefit to patients and getting them on the right treatment and better response. And then, as a company, we have a number of scientists. We're at the core. We're a very highly scientific team. We have a number of physicians in-house. We work with physicians and our healthcare partners. And we really believe that AI has to be applied in a way that doctors and the medical establishment can trust. And so we always start, at its heart, what is the clinical question? And how can we deploy this in a way that fits into the model and the framework of screening and framework that is, in the medical system today, rather than asking for large-scale disruption and doing something that's never been done before? We're really kind of augmenting and improving the outcomes and utilizing the system, transcending some of the complexity of the system, but really, kind of fitting within the current kind of clinical paradigm. We're building for scale. We're really focused on making this low cost, deployable. And of course, we have very high bar on the clinical validation and making sure that our machine learning and AI is trusted, that it's trained on, kind of prospective, true screening populations, that it's FDA approved, and we're in that process today. We have breakthrough designations, I mentioned, with the FDA. And really meeting the highest bar of evidence so that it can be trusted. And with that, we know that we can make a huge difference. And I'll come back to kind of where I started, that genomic AI is one of the largest opportunities in healthcare. And I think it's going to impact all of our lives and, save millions of lives. And with that, maybe I can take some questions if there are any.
Hi, Susan. Thank you very much. It's been great insights. And as a cancer survivor, I know how important to be diagnosed as early as possible. And this is an amazing new technology that is really progressing well. And I'm very excited about it. I'm sure there's plenty of questions, but unfortunately, one of the things that let me look at quickly on the questions perspective, there's a couple of questions. I'm just reading it. You emphasize that single target biomarkers miss critical early cancer signals. Could you elaborate on what types of genomic patterns or structural features the whole genome AI approach can detect that traditional methods constantly overlook?
Yeah, I mean, some of it was in that graphic that I showed, which showed that, all the alterations that are happening in, this kind of chaotic pattern of cancer. When you look genome-wide, you see that, these alterations, such as the amplifications, deletions, the chromosomes that are kind of doubled up, or those that aren't, things that are as simple as just the fragment length variation in the case of cancer is much more erratic than, in the case of non-cancer. The fragments are much more uniform in that kind of 160 to 170 base pair kind of length. If you're looking at just the amount of DNA at any point on a chromosome, it's going to be much more variable. So all of these things, and copy number variation, I mean, all these things are kind of put into this like broad signal that we detect, and kind of lead to this like millions of data points that we train on rather than hundreds or
Sure.
thousands.
Quick another question. It says because the Delphi's model relies on the data that exists, how do you plan to ensure equitable access for underrepresented populations?
Yeah, it's a really good question, and I think is something that we take very seriously. We've done a number of studies in kind of our research phase. We did these studies with nations, across. Representing the world, so we had that to train on, and then as we've done our clinical trials, and this is for our FDA filing, we have been very systematic in making sure that our trial enrollment, and I'll take the case of our US trial, which is a 12,000 patient study, which is a real cross section of the US. And we made sure that we had representation from like all the ethnicities represented here. And, thankfully we are a very mixed race in the US. So, we have a very good kind of diversity represented there. But it's something that we take very seriously. And, we're excited to work with collaborators across the world to bring more diversity in our training data.
Thank you very much, Susan. Really appreciate the talk, and I'm sure through LinkedIn and your email, etc., people will get in touch with you to understand a little bit more on there. I'm looking forward, and I'll be following you and Delphi on the LinkedIn.
Thank you so much. It's been a pleasure. Thank you.
Thank you. Next speaker is Lepora Flournoy, and she's approaching this very different point of view. And she's coming from organizational development, and she has a degree on sociology and psychology. And she's about to release a book. I'm looking forward to reading it. Is How to Build Strong Culture. And I would like to welcome Lepora Flournoy to the presentation. And it's great to see you. And I love the approach that you are having on the different points of like ethical perspective, leadership perspective. How is this AI and overall health care business is going to change? I'm looking forward to your presentation.
Thank you. Would you like me to upload it?
Yeah, go ahead. Share your presentation while we are checking to make sure that is showing nicely. Okay. By the way, I love the concept of, human operating system. So let's drill down. It looks very good, the presentation and the video.
Thank you. So it's a pleasure to be here, and thank you for the invitation. It's been really good information that I've been gathering, even myself, throughout this day regarding AI technology and healthcare, which is so important. It's going to make such an impact. So it's just an honor to be part of such esteemed guests that you have here presenting. As you mentioned, I'm Lepora Flournoy, CEO of Next Gen People, and our focus is very much on AI. However, we are focused very much so on that leadership aspect of AI, that people aspect, and that transformational change, because we know without the change management, without the transformation, without the leadership aspect, we just have a tool that is limited in its usage. So our focus is really on how can you not just implement AI within your healthcare systems, within your R&D operations and biotech and pharma organizations, but how can you sustain those benefits, which are going to be very important in order to reach the success that you want to reach. With the end in mind, what we're going to focus on today, really creating that appropriate blueprint for AI-ready leadership, identifying the tools that you're going to need to reduce that friction at the top. We know that everything comes from the top to the bottom of any organization. Even the flattest organizations have some level of top. And so that top can poison the bottom, or that top can really cultivate and build fruit throughout the entire organization, where you have something that is healthy and sustaining. And that's what we want for your organization: sustaining cultures, sustaining people, healthy patients and clients, and at the end of the day, ensuring that you are able to sustain your organization for a very long time. The diagnostic lens that we'll be looking at is through that lens of those leadership bottlenecks. Those bottlenecks can be either what leadership is doing or what leadership is not doing. And that's very important for us to focus on that, because behavior can be effective positively or negatively regarding what is done and also what is not done. And then we're going to look at what we recommend to you as an appropriate 30-day roadmap to get yourselves ready for 2026 in order to accelerate that transformation, which is going to be really appropriate for every single organization. So why does this matter? And why does it matter now? It matters because, for one, obviously, we know everyone is going at a very fast pace because AI is driving that pace. But it also matters because when we see digital transformations fail, they're largely failing due to leadership behavior, not because you've chosen the wrong technology tool or the wrong AI. Usually, most of the time, 70% of the time, digital transformations are failing because of leadership behavior, or as I mentioned before, the lack thereof. So we want to ensure that your transformations not just start, but they are successful. And what's interesting, I will tell you, is that over the past, I would say 15 to 20 years, working in the change space, when you heard that word digital transformation, if you were not directly connected to technology, you sort of blocked it out. Like, this is irrelevant. It's not really important regarding what I do. But what is going to be different, and what we are already realizing that is different, and especially going to be different in 2026 and beyond, is that digital transformation is everybody's business. It does not matter whether you're in healthcare or in any other industry, whether you're in a large organization or a small organization. Digital transformation is going to be that primary focus, and it's going to be required because now we are living in a world that is going to be largely driven by AI and AI advances. And we're not going to have the luxury, as we did perhaps before, to take our time in manners and test and retest and retest. And it's not about a normative opinion about whether or not that should be the case, but that's just going to be the reality that we'll find ourselves in an environment that is going to be moving very quickly. And I'm sure you all are already feeling it. And you're going to either have that option to adapt very quickly or to not, to implement those solutions quickly or to not. Because if you don't, then someone else will, and they will look for others to provide that source that they need in order for the solutions. And what we want to ensure is that the solutions that you have, those most effective solutions, make it to patients so that we see better outcomes, better livelihoods, and greater longevity for the entire global society. But we have to do this in a way that is going to honor the speed of AI and those around us. And so, looking specifically from the lens of healthcare, the leadership reality is one of obviously greatness because you are saving lives every single day, but it is also one of challenge. And that challenge is going to be, I believe, felt more greatly in healthcare than any other industry with this AI wave. First and foremost, we're seeing major burnout. We're talking 40 to 70% of healthcare populations are experiencing burnout. And I know I don't have to tell you this because you're living it every day. Why is this burnout happening? For one, because we have some skill sets that are limited, right? Everyone does not have the skill sets that are needed within your industry. Everyone doesn't have the skill sets to work in the hospitals or to develop the clinical solutions that you're doing front and center. And therefore, those individuals that we are relying on are limited. And it's creating burnout that we've never seen before, up to 40 to 70%. So much that we're seeing retention that we had in the past much lower. So those attrition rates are significantly challenged today as we see professionals in the healthcare in a variety of areas of healthcare resigning and leaving and choosing other careers at unprecedented rates in the past. And so this is the time to identify, how do we retain that good talent? How do we ensure the AI that we adopt is going to help hopefully alleviate some of that burden even on the talent that exists so that we can retain them and bring the best out of them long term. Decision speed we're seeing in healthcare specifically over the past recent years has decreased, which is a great challenge because what we're seeing overall is this increase in decision speed. And we're definitely going to continue to see a requirement of increase in decision speed as AI advances on a very fast pace. If you've been following AI even a little bit, you will see that even if you skip a week, you've missed quite a bit of AI development and news within all industries. That's only going to increase and require that decision speed to significantly increase as well. As far as AI adoption, we're seeing that happen 5 times faster than the readiness. So what does that mean? That means the systems are being developed and introduced 5 times faster than your teams are ready to receive it and implement it. So obviously that speaks to organizational readiness being a very important focus. From an engagement perspective, we're seeing 70% decrease in engagement. And this is largely due to unclear leadership. What we need are systems that are not just technology based, but are leadership based. And that's going to affect the speed, the ability for your organization to move with haste. That's going to be very important going forward. So, I've talked, and thank you for mentioning this leadership operating system, this human operating system that's going to be very important. And while the human obviously is most important because that's who's going to drive everything getting done, even 10 years from now, when AI is at its prime, we're still going to need humans to drive those decisions. And so when we talk about humans, we can't talk about humans within an organization without talking about the leadership, because the leadership is going to drive what is going to be experienced by your teams, your organization, and then ultimately drive what's going to be experienced by your patients, by your clients. And so what I've done is put together these 4 pillars of layers for your leadership operating systems that I'm challenging you to implement within 2026. 2026 is going to be a pivotal year, and that's why the timing of this conference has been so important. This healthcare, specifically focused on tech, is so pivotally important to be held within December of 2025, because 2026 is going to be a monumental year. 2025, we've seen the introduction of a lot, but truly 2026 is going to challenge leadership throughout all of your organizations. And so that's why these 4 layers of operating is going to be crucially important, more important than before. There may be things here that you've taken for granted, that you've heard and taken for granted. But in order for your organization to stay healthy, to be healthy, to compete, trust me, these are going to be very important. And those layers include an identity layer, an interaction layer, an intelligence layer, and ultimately an integration layer. And that integration piece is really focused on what your organization actually does with 1, 2, 3. So it's very good to have the appropriate mindset, the appropriate ideas. It's important to have the right communications even. And of course, it's important to have solid data that speaks to factual information that you can make your decisions off of. But these steps are not integrated in a way that equals the behavior of your organization, that equals the right culture, the right synthesis as far as what the leaders are doing all the way to the bottom, and how they use technology and how they lead and how they make decisions, then it's not going to work. It doesn't matter how great the ideas are, how great the communication is, or how great even your data is, if you're not integrating this into consistent behavior. Deloitte has even shared with us in 2023 that systems, that teams that are integrated are at least 2 times more likely to sustain transformation. And that's what it's all about in this conversation beyond. It's about sustainability. It's not about you checking the go live button, but it's about you truly being around and thriving successfully year after year. And that's what we're really after. So these layers are important, and want to ensure that when you're looking at your organization, you're designing these layers in a way that is customized, that is authentic to your organization, because that's the only way it's going to last. He mentioned my book, The Making of Stronger Cultures, and that is all about intentional organizations. And the reason why I mentioned the book is because it's very appropriate here with respect to making sure that you're designing an organization that is authentic. If you have ideas that just look good on paper, but you don't have the courage to communicate them, it's not going to last. If you communicate something, but then you don't use the data to drive accountability and rewards, it's not going to last. And if you don't require that appropriate behavior and culture that you deem important and correlated with the goals of your organization, whether it is developing new solutions, delivering top-notch service to patients, operating procedures that are error-free, if you are not driving these activities, these behaviors, or lack of behaviors through your culture consistently with rewards and accountability, the chances are your system is not going to last in this increasingly competitive behavior. First and foremost, want to focus on the identity layer. And the reason why is because everything starts here. And I like to look at identity layer as the minds really of your leadership. Everything starts with your leaders. The identities start with your leaders. I know there are organizations, like I mentioned earlier, that are flatter, that are more empowered. And we're going to even talk today about how important it's going to be for organizations to be more empowered and flatter. But at the end of the day, you're going to need strong, consistent leadership. That leadership is adaptive. And the reason why your leaders are going to need to be adaptive is because you're going to now need to trickle down those same mindsets throughout your organization in order to increase and create that faster transformation, that 3.5 times faster transformation that organizations are expecting with AI. You're only going to be able to take advantage of those if your leaders are adaptive, if your people are adaptive. You're only as adaptive as your people regardless of how advanced your technology systems are. So today is today to upgrade that thinking, to upgrade your outcomes. And so we talk about that interaction layer, and that interaction layer is that focus on communication, because now you're going from having those ideas to now communicating what those ideas are to your people, to your frontline individuals, your patients. And in order to have true interaction, you have to not only have that clear communication, but you also have to have clear understanding. Clarity is going to be that true performance accelerator for your organization. If you're not clear in what you say and what you require and what you request, and if that is not clearly understood, then you're going to have challenges. You're going to have bottlenecks. Clear routines equals 42% faster execution. And speed is going to be the name of the game. And I know speed is not always that word that you want to hear in R&D or when you're developing, especially medical or technological advances related to health. But speed is really going to be the name of the game, even in healthcare. It's going to be how you can do things faster. And that's going to be really what the focus is going to be based upon. And then, of course, the intelligence layer, which is the star of the show here, because we're talking about that technology. So people here appreciate the value of what technology brings, including data, including being able to make faster decisions. And so if you have faster data and you have leaders who are data fluent, using data to make decisions, then of course that is going to lead to faster execution. MIT, Boston Consulting Group, they see 58%, at least 58% faster execution with leaders who are data fluent. And I would tell you, a leader who is not data fluent in 26 and definitely by 27 is not going to be of value, and I would say not going to be able to survive in this near future AI environment. AI is going to be a tool that is going to be very powerful, but also useless without appropriate interpretation. And again, this goes back to how important our leaders are, how important our teams are as far as having that consistent behavior. That integration layer, again, we're going back to this because this is where the rubber meets the road. So you're going to have the leadership mindset, you're going to have the communication and that interaction, but you're going to very importantly need that intelligence to now be synthesized with those components to lead to behavior. And that will focus and show one organization, everybody's aligned in their mindsets and their goals and what they do, leading to that one rhythm, leading to that one human operating system. That is going to be what is going to be required for the sustained transformation, the sustained success for any advances that your organization makes. What you will see in 2026 is an overwhelming number of AI transformations within organizations. What you will see in 2027 is an overwhelming number of organizations that will not be able to make the cut, that will not sustain. Sustainable transformation appropriate change management, appropriate managed transformation is what is going to be sustained in 2027 and beyond. So what are those things that AI requires of leadership today? These are 4, hopefully not new behaviors, but these are 4 behaviors that are going to be newly required in a way very different than before. Number 1 is about orchestrating and not controlling. It's about empowerment. While leaders have very important roles that they serve, leaders are nothing without everyone who's operating beneath them. So it's not about control right now, because everyone in your organization is going to be at least 200% smarter due to AI. And so that is going to empower decision making at levels that were not able to be empowered before. So the leader is going to be needing to orchestrate, making sure that the agreed upon decisions are happening, making sure there's alignment and mindset, that there is follow through, that there is confirmation, that there is validation reviewed, but not controlling. This is a time and era of empowerment like never before. Secondly, and this goes with number 1, leading with data. This is a time where opinions really are not going to be as valued. There's something obviously to qualitative information. There's something to that gut check, that gut feeling of 20 years of experience. That is going to still be very relevant and very important. However, that data is going to trump. If you don't have data to confirm, to support your decisions, there's going to be a lack of credibility there, not only in your marketplace, but in your immediate teams. Thirdly, making sense of complexity. This is a time like never before where we have been tooled, equipped to really dive through and drive through complexity very quickly. And so this is going to be expected. Your clients, your patients, they're going to expect for you to make top sense of complexity, because not only are your team members going to be smarter, your patients are going to be smarter, your clients are going to be smarter. They're going to be bringing solutions to you that they've seen through AI, through their lens. And so now the bar is going to be higher, significantly higher, for you to make sense of complexity. Not just make sense of complexity, but make sense of complexity at a much faster rate. And number 4, collaborating across disciplines is going to be vital and key. And that expectation is going to be that you are now bringing more than what you brought before, that there is a sum that's larger than your team, than your organization even. Collaboration is going to be the name of the game to not only, 1, take advantage of those new technological healthcare advances that were not available before, but also to be competitive in an environment that's going to be very competitive. And when I say competitive, it doesn't mean that everyone competing is going to be bringing the same level of value. So as your organization brings significant value to the marketplace, you want to ensure that it's heard. And in order at times for it to be heard, it's going to need to be collaborated with others in order to be stronger, because we know 2 are greater than 1. And this is going to be no exception in the near future. So firstly, digging more deeply into that first shift of orchestrating. Decision pods, I'm strongly recommending every organization that's listening have decision pods. And these are your teams, basically your thought tanks within your organizations that are ensuring that decisions are being made at a pace that makes sense, and more than likely at a faster pace, quite frankly. We want quality, but we're going to have to make decisions faster. So no longer is it we're going to have the luxury of administrative bottlenecks, of 5 people reviewing things when really it could have happened with 2. And if you create these decision pods, some call them toll gate authority systems, different names people may use, but the bottom line is a committee that is identifying decisions, important decisions that need to be made at a pace that makes sense within your organization. Have these people as people who are gatekeepers, yes, but they're also people who are focused on effectiveness and efficiency. So they want to see quality continue, but they also want to see speed increased. It shows that organizations that have these decision pods make decisions 40%, 60% faster than they have in the past. Again, it's going to be about stopping to approve things and starting to orchestrate things. So having these pods throughout your organization helps to break down those hierarchical layers and make decisions at more local levels much faster. As we said it before, this shift is an obvious shift, I'm assuming, for everyone listening to this call today. And that is about leading with data. Data first teams, they are 72% less likely to have strategic drifts and more focused. 72%, I would interpret that to mean 72% more focused on making fast decisions that are aligned with their strategies. Otherwise, there is going to be that tendency for team members, for leaders, to get distracted by their own ideas. The more you can lead with data that supports your goals, supports your organization's strategy, the more likely you're going to focus and get things done faster that align for the entire organization. Again, as I mentioned earlier, evidence over opinion is going to be a very, very important way for you to practice, because everyone is going to have evidence. And so they're going to expect you to have that factual, objective evidence as well. Shift number 3 is building sense making, and that's about interpreting skills. That's about, again, those leaders who are able to interpret that data. And what you're going to see is 4 times faster adaptation to what you're working to accomplish, because leaders are not only going to be able to lead, but they're going to be able to use the data to interpret. Every leader, I mean every single leader, 100%, every single leader is going to need to be a leader that is able to interpret data, to drive decisions using data. That is not going to be a negotiable going forward. Leaders must make meaning and not noise. And that meaning comes from objective information, not from perspectives or opinions that are solely based upon preferences, but based upon what is the data saying today. If you're not focused on what the data is saying, you're not going to be competitive going forward. And the shift number 4, again, as I mentioned, is going to be all about that cross collaboration, cross-disciplinary AI squads. It's not going to be able to, organizations are not going to be able to no longer tolerate silos. We know silos are very common, especially the larger your organization gets. But organizations that maintain siloed behavior is not going to survive, because there are going to be those other organizations that are going to use collaboration to their necessary advantage, and in order to increase and create and produce and provide for their clients, for their patients. So those multidisciplinary teams is going to be the name of the game. And as we see those teams, what we see is individuals, teams understanding what the others need, and not only collaborating to provide for those multidisciplinary needs, but creating something new because they are collaborating and providing for those needs in a way that is more collaborative than ever before. Organizations that have effective multidisciplinary teams see 4 times faster adoption and sustained adoption. Innovation sticks when innovation is solved together. So that's going to be a very important piece, that collaboration aspect. And shift number 5 is focusing on the human cost and reducing that human cost. That means having that high clarity leadership, making burnout a leadership problem, not an individual team member problem. 30% less burnout is likely when you have leadership focused on it with clarity. So burnout should not be something that just happens, that is just a hazardous outcome, but it should be something that is tackled and challenged by your organization with effective intelligence, with effective leadership and clarity of communication, and with collaboration that equals sustained results that are easier to see followed. Shift number 6, again, is this ultimate AI-ready executive team. It's about decision speed. I put less than 7 days here, even though we know some decisions you're going to need more than 7 days. But this should be a regular goal. If a decision is taking longer than a week, that decision should be enormous for your organization. It should have enormous impact. If it does not have enormous, long-standing impact on changing or making that decision should be able to be made within 7 days. And if it's not, there's probably something wrong with how your organization is operating. Too many bottlenecks, too many hierarchies, indecision, lack of focus or understanding on what is happening in the moment. Hands are not on the pulse. So 7 days or less for your regular decisions. It should be a very significant decision that is going to need to take more than 7 days. Your rationale should be transparent. Goes with that clarity. If it's not clear what your team members and your teams are receiving, what's going to happen is that they're not going to be able to implement. Behavioral accountability is going to be more important than ever, because you can say anything, you can make a decision, but if it's not executed, that's going to be a significant challenge for your organization. EQ and conflict fluency, again, is going to be very key, especially in an AI dominated environment. We talk about the AI literacy, that's an obvious requirement. But if you don't have emotional intelligence, if you don't have ability to have fluency in managing conflicts and leading conflict resolution, your organization is not going to survive. And this is what's going to be especially important for leaders, is being able to solve conflict. Because what's going to happen is that organizations that are not able to do that are not going to be able to sustain their AI. And that's going to be the differentiator, because AI is going to be able to implement technology. However, are we going to be able to sustain the human system that's going to be required in order to keep that technology? So I challenge you with this 30-day blueprint. Identify your leadership bottlenecks immediately. Set your new operating principles. Launch those decision pods throughout your organization to make decisions faster. Make sure you have a cross-functional, collaborative AI squad that is communicating the architecture of your system, your culture system, and your technology system, and how it's changing day to day. Your competitive advantage is going to be not only your technology design, but your leadership redesign. So look for that improvement that we know you can see transformatively within your organization by making that transformation start and consistently continue with your leadership. Thank you very much, and I appreciate your time.
Thank you very much, Dr. Lepora Florney. And I really appreciate your insight about the leadership, what's needed in the AI. I love the concept of, like, don't forget the foundational stuff that already exists in every leadership position, but leverage the AI and all the new concepts to it. I like orchestrate, don't control, lead with data, make sense of complexity, and collaborate across disciplines. So there's several questions, but I would like to move that to LinkedIn, and they can follow you, and we'll continue the question answer part in there. Thank you very much for that. And last but not least, one thing, if you say one word to our leadership today who's dealing with the AI, what would that be?
That one thing would be to stay consistent in your learning. Stay consistent in your learning, because that's going to help you to lead with excellent consistency.
Excellent. Thank you very much.
Thank you.
Thank you, everyone. And last but not least, unfortunately, due to emergency, Michael Archuleta won't be able to be with us. So we are going straight to Suni Southern, who's the founder and CEO of Viable Synergy. And we're going to talk about the scientific impact with AI, talking about the real world impact and how is this going to work. And I would like to welcome Suni to the discussion. Hi, how are you?
I'm great. How are you?
Great. And I love your background being nutrition and the great degree of education in there. Then not only you've done several startups, etc., but you also work in the corporates like Google, etc. That is part of the technology transition. So I'm looking forward to hearing your overall concepts, and we'll talk after the session.
Sounds great.
Let's see your presentation.
All right, here we go. Will that work, Murat?
Yes, it looks really good. You are looking good, and the slides are looking good.
Thank you. I'm sorry about Michael Archuleta, but I'm really, really happy. I hope everything's okay with him. And I'm really, really excited to be all. This was I was really felt honored and privileged when I was invited to participate today. And I'm super excited to talk to you and share some thoughts about how we can amplify scientific impact with AI and accelerate the research lifecycle from discovery to real-world impact. All right, so our purpose for today, we're going to discuss how AI scientists and researchers, sorry, that was actually my notification for the next part of the talk. So our purpose for today is to discuss how AI can help scientists and researchers spend less time on manually searching across databases, journals, and internal documents, rereading and summarizing the same concepts for different audiences, and synthesizing evidence across multiple sources one by one. We know it's critically important for scientific publishing as well as for commercial applications, and yet it takes a lot of time. And so if we can use AI to reduce the time spent on these essential but time-consuming tasks, then researchers and scientists will have more time for thinking deeply about what the data really means, exploring bold hypotheses in new directions, designing stronger studies and protocols, and collaborating with colleagues across disciplines. And we're going to talk about how effective and responsible AI can enable researchers and scientists to reclaim those breakthrough discoveries that what you really want is greater real-world impact. We all want that. So a little bit about my background and about Viable Synergy, my company. So as Murat said, I'm a dietitian. I have a master's in human nutrition and foods, and I still keep my licensure in Ohio. I am also the founder and CEO of Viable Synergy. I have quite a bit of experience, as you can tell. This isn't my first rodeo. I've been doing this for over 15 years, and I've worked across life sciences, healthcare, and advanced technologies. I have experience at kind of an interesting intersection where I've worked in pharma at companies like Sanofi and Takeda, and as well as at Google and at Verily. And I've worked with hundreds of startups. And Viable Synergy, the company that I founded several years ago and have refocused in AI about a year ago, is an intelligent technology company. And we help life sciences organizations use AI to solve critical problems today and adapt to tomorrow's demands. And I said I was excited and felt privileged to be here today. And that's really because you probably know from a nutritional perspective, misinformation is out there and how challenging it is at times to determine what is most scientifically founded from a nutritional consumption perspective. And so with the age of AI, we're in a position where it's more important than ever that we get credible science out into the world. Credible science deserves to be found, and we need more breakthrough discoveries to reach the people that need them faster. I think everybody would agree with that. We don't want to lose the rigor, though. So we're going to talk about that today. All right, so our discussion topics: the reality of research work today and why it's accelerating. We're going to talk about the foundations of effective and responsible use of AI assistance in life sciences. We're going to share several specialized AI solutions for life sciences organization teams. And then we're going to talk about something that's brand new. It's called Geo, and it's a way to make your research more visible to AI systems. And then we're going to put it all together and talk about the impact that can be when it all comes together effectively in unity. All right, so let's talk about the essential work. As researchers and scientists and those who work in life sciences and healthcare, you understand that core research tasks include, like we said before, the searching across literature and data and all the prior work, summarizing complex findings, and needing to translate that into a myriad of different audiences. So sometimes you're speaking to your peers. Other times you're translating that information to executives or your operational stakeholders. And then other times you actually are communicating directly with consumers. And then it's important to synthesize the data and insights across studies, sources, and disciplines, and this all takes a lot of time. These activities are essential, but they're not usually optimized. And that they're central to scientific quality and integrity. But again, it's time consuming when you have to do them manually. And so these types of tasks take away from your ability to think deeply and explore new ideas and be creative, get strategic, and then work cross-functionally. It can feel like a time drain. It can feel like big time drains. And so we can use AI to help us to reduce those. You probably are all feeling it. We know that we're seeing it all around us and in the news, that the research landscape is definitely accelerating. And in some ways, fortunately, it's expanding faster than people, processes, and systems can support it. But for those of you, the foundation of research discoveries and scientific outputs, it probably can feel overwhelming and a bit challenging. And just want to validate that for a second. Let's talk about 4 different areas where the research landscape is accelerating and changing. The amount of data and the complexity of the data is significantly increasing. I was pretty shocked to find that just in phase 3 clinical trials alone, we're now generating 5.96 million data points. And so let's put that into perspective. That's a 541% increase just since 2012. And this is information that's hot off the presses. It was just published recently in 2025. So that means scientists and researchers have to cull through more data. They have to be responsible for putting that amount of data together. And then all the people downstream that have to review the data, it creates an incredible amount of time and burden on people, especially if it may not be as relevant as it needs to be. I talked a little bit earlier on about the information explosion and the challenge, frankly, to credibility. You're probably familiar with open access journals, and now 80% of global research articles are eligible for immediate open access. So in some ways that's great because we're getting more research out into the world faster through these open access journals, but that also means more information is available. And so we need tools to help us to make sense of that, whether you're trying to find potential ideas or to see if there's something similar that's already being worked on, or if you just need to have citations for some of the work that you're already doing. And unfortunately, up to 1 in 7 submissions are flagged as suspicious in recent publisher pilots, which is very concerning. And it's something that, again, as a dietitian, it's frankly frustrating when unfounded or inaccurate or maybe just not complete information makes it out to clinicians, stakeholders, my peers, and to the public, because that means that those of us that are still trying to support good science getting out there, like most of us, then we have to overcome the information and try to find more credible ways of explaining why that information isn't necessarily accurate. Behavior and adoption. You might be surprised that 58% of researchers are actively already using AI tools. And again, let's put that into perspective. That's a significant increase from 37% just a few months prior. So the acceleration of the use of AI tools in research is pretty profound. And then you might be saying, okay, great, people are putting a lot more information out into the world and they're using AI to help them. But is that information accurate? Is it credible? Is it reliable? And what are publishers thinking and seeing when these papers submitted that have been supported with the use of AI assistance? Well, again, I was really pleasantly surprised and excited to share that researchers, the research shows, it was Howe et al. In 2024, that when researchers utilized AI assistance, they published 67% more papers. Again, were they good papers? Well, peers said that they must have been because they received 3.16 more citations. And this is, I think, the really, really important statistic when we look at it all together, that 18.6% of those papers were more likely to appear in top tier journals. And so the researchers that are using AI and using it effectively and responsibly, more citing their work, and they're getting published more often in top tier journals. And there are a lot of reasons for this. AI can make it easier to use and get information and insights from more robust amounts of data. It also, which I love from a great equalizer perspective, it helps people whose first language may not be English to produce better written papers with less grammatical and typographical errors. And that to me is fantastic, because I don't think that great research should be bound based on where someone was born. It should be available and made easy for people who speak any language to get great research out in the world. Now, with all this being said, it's no surprise, and I'm sure that you are feeling it if you are a person responsible for producing research or scientific findings, that the expectations for speed, transparency, and reproducibility also continue to increase. And so researchers need tools. This provides a growing opportunity for scientists and researchers to expand the reach and impact of your expertise. This is a pivotal moment for research. As expectations are increasing faster than available time, AI tools are rapidly advancing. They are getting better and better and better, and there's more and more and more of them, and they're being more quickly and pervasively adapted into the daily research workflows across the research lifecycle. I just showed you some data that showed that individuals and teams that use AI effectively are accelerating their insights. And for teams and individuals who are not using AI and are not producing papers and evidence and content in a way that can be readable by AI, they really risk losing all visibility in a world that is highly AI enabled. So I'm going to tell you a few tips about how to use the off-the-shelf tools effectively and responsibly to accelerate some of your work. And then we'll talk about some specialized tools for research. So I think about effective and responsible use in essentially 3 ways. So there's a step before you prompt. You need to make sure that you're still in control. We'll talk about that. The prompt. You keep hearing about prompts, I'm sure, and if you're using AI a lot, then you know how important getting the right prompt and using the right prompt is. And then I can't emphasize enough that humans are essential. We need to stay in the loop. Our expertise, our judgment, our taste needs to be part of what we produce. And we need to make sure that we really use what makes us special to ensure that what we put out into the world, people see and understand and relate to, and feels authentic and is accurate, so that it gets cited and used. So firstly, before you prompt, before you type anything, maybe even before you sit down and decide what tool to use, really, you want to sit down and you want to define the problem that you're trying to solve, deconstruct the work that you're going to do, and define what outcome that you're looking for. So we can't use tools like ChatGPT or Claude or Gemini or Perplexity in the same way that we used Google.com. We need to be more robust. We need to think about AI assistants as an assistant and use them, share information with them like you would a trusted assistant or a peer that's going to help you get something done. The prompt. I use a methodology called the 3 rights. It's really important that you start with the right data. So what data are you going to use to inform the prompt? And data in today's world doesn't mean just tabular data like it used to. Data could be your previous publications. It could be a publication by someone trust, not plagiarism, but just showing AI assistants what good looks like. And then, of course, there's also the tabular data that you'll want to include. But figure that out first. Figure out how much. You don't want to just go point your AI assistant at your entire SharePoint site with all of your previous information and expect that an AI assistant is going to be able to cull through all that and give you results that are meaningful, accurate, and relevant to what you're actually asking it to do. Just like you wouldn't do that to a human assistant, you don't want to do that to an AI assistant. That's what increases the hallucinations, and it just is going to take you more to then try to review the results. All right, right tool. So again, before you prompt, you want to make sure that you're using the right tool and configured it the right way. So are you going to use, for example, are you going to use Claude in a project and you're going to build a project around this? Is this something that you're going to repeat often, or a project in ChatGPT? And if it is, if you are, for example, developing, really writing an entire paper, you may want to go ahead and set up a project, and so that you can do chats in one area, just like you would create a folder in your Google Drive or in your on your computer or in your Microsoft SharePoint. And then you want to make sure that you are configuring it the right way. Do you need deep research? Deep research is incredible, but if you use deep research, you're going to get back a lot of information. I love using Gemini's deep research function when I want to do deep analysis and really have a research assistant go and find a lot of information for me. And I use that to help me find the stats that I presented earlier as an example. Or do you need a faster answer, or do you need AI to think? So it's really important that you choose the right tool, the right model, and the right configuration. And then you want to use the right technique. So that's prompting, right? You want to know that you're providing. I like to use, tell it your role. Who are you today? Then tell it its role. Tell the AI, do you want it to be a research assistant? Do you want it to be a thought partner? Do you want it to be a great copywriter? What are you looking for? And then, so after you tell it your role and its role, you want to tell it the task. You want to tell it the output structure that you're looking for. Are you looking for a very succinct, 50-word summary, or do you want a very robust bulleted list? Do you want a table? Tell it what you need. And then again, humans are essential. We need to keep ourselves in the loop. We need to use our judgment, our interpretation, and our decisions. And I'm going to put a little plug for this. As someone who reviews a lot of AI content, is frustrating when someone just takes an output from ChatGPT or Gemini or Claude and just throws it across to you, and then you start looking at it and you start asking questions, and they're like, oh, well, I didn't review it enough, or, oh, that was just what I got out of my ChatGPT. It's like, I just spent an hour and a half reviewing something that took you 10 minutes to produce. Take the time. Let's make sure that we don't just spread AI slop, basically. So with the right foundations, AI becomes a reliable partner in the research lifecycle. All right, now let's talk about when general purpose AI tools are just not enough. They're fantastic. They're kind of like a Swiss Army knife. We're also hearing a lot about the amount of energy and resources that these large language models take. So sometimes we need a more precise approach to what we're trying to do. And for those tasks that are highly repetitive from a scientific or research perspective, they're highly structured and time consuming. There are some really great tools that can help save you a whole lot of time. So the previous slide, when we talked about thinking about it before you act, which is always going to be important, then we make it a lot easier for you to be able to quickly do repetitive work in a structured way. So let's talk about what those are. So Viable Synergy, we create specialized tools for life sciences, and these are purpose-built tools that automate repetitive, high volume or high stake tasks. I'm sharing three here today, but we create a lot more than this, and we also do custom solutions. So from the first one we're going to talk about are AI smart spaces. So AI smart spaces are workspaces that are powered by AI, and they produce compliant and consistent documents. Because of the way that we configure them, they use information that we call golden. So you choose the types of information, the data and insights and information that you want to power repeated types of documents that you create. They generate documents that are on-brand compliant, like protocols, reports, communication materials, even legal agreements that can be tedious to create, but they're essential. And then enable our users to ask natural language questions. And so it helps you to find that information more quickly, but also to direct the AI either by typing or speaking, so that you can create things like policies, SOPs, and guidance super, super quickly, or update them. And then the way that we configure using these AI smart spaces is that we use what's called role-based access control with auditability, so that it also ensures that we remain compliant and builds your trust that you can use these things quickly to accelerate work. So specialized AI scouts, what are those? So AI smart spaces are primarily designed for documents. Specialized AI scouts are more designed for tabular types of data, so structured data. These are always-on assistants that monitor and update and enrich structured files and databases. So they can automatically update a database of, for example, claims, potentially a CRM system, a customer relationship management system. They automatically, using validated internal and external sources, will make updates. And again, we enable language questions. So instead of having to click through hundreds of screens or filter, through hundreds of different variables, you can just ask natural language questions and then receive real-time insights. And then you can compare or on comparisons or reports. And then we enable track changes visually, so that's really easy to see. You can track the changes visually, so that's really easy to see things through dashboards and alerts. And the last we're going to talk about today are what we call persona-based simulations. So typically we think a lot about AI as something that helps us to use historical information to help inform today. AI is also great at giving us an opportunity to simulate many different scenarios that we can try things out, and then we can see what's going to work the best, and then we can make more informed decisions about how we're going to impact tomorrow. So we develop these AI personas that simulate high stakes situations. They do things like allow you to model responses or be able to practice, if you will, what an exchange may be from your peer reviewers on one of your papers, or by regulators for regulatory submissions, maybe by clinicians, if clinicians are your primary customer, or customers if consumers are. It allows you to anticipate questions that you can then respond to, and it's like practicing for an interview, but for many different types of high stakes scenarios. And what it does ultimately is it improves for reviewers, decisions, and scientific dialogue. Okay, so some of these stats you will have seen before, but I thought they were so important that I wanted to make sure that we brought them forward again. And they're also really a foundation for what we're going to talk about next, which is how you get found. Make sure that your research and your scientific findings actually make it into the people that can use them and make a difference. So AI, essentially AI assistants like ChatGPT or Gemini or Claude, are becoming a primary for scientific knowledge. And the shift is happening where LLMs now answer many informational and complex research queries. So consumers, peers, clinicians, executives are using, again, like ChatGPT and Gemini, to go and ask really complex questions and get great results. Now, are they always accurate? Depends on how they're using them and if they check the facts, but it's our job to make sure that our information gets out there so that it's included in these responses. And then research visibility today really depends on how AI systems interpret that content, and that's only going to continue. So again, we talked about that 58% of researchers are already using AI tools. And when researchers and scientists use AI assistants, they get 3.16 more citations. There's 67 more papers published and 18% more likely to appear in Tier 1 journals. All right, so how can you ensure that your research and scientific findings make it into the answers that ChatGPT, Gemini, and Claude and others are providing to people who are asking questions. So we're going to focus on something called GEO, which is Generative Engine Optimization. And what is it? So it's the practice of structuring scientific content so AI systems can retrieve, interpret, cite accurately in generated answers. Where it also, so the term GEO originated at Princeton, and the GEO framework from Princeton is visibility equals retrieval, inclusion equals interpretability, attribution equals citation, and optimization equals structuring content for these outcomes. And structuring content for LLMs is actually quite different. It may look the same, but the thinking behind it is different than what we think about for a typical scientific publication, although scientific publications work really well for the way that LLMs think about how they interpret this information. And then why does it matter to you, and why does it matter today? Again, we've talked about this, but generative engine optimization, things that you can do, is required for visibility today. So AI assistants are increasingly determining what research is surfaced and trusted by large language models. And it's important to know that if AI can't read your work, it can't use it to respond to queries. So if you're publishing your papers and you're not following good practices for making sure that your information is visible and structured in a way that LLMs can review it, then the assistants aren't going to see it, and so it won't show up. And then scientific impact is increasingly dependent on making sure that your research and scientific findings show up to these generative AI tools. So our preferred generative engine optimization platform is called LLM, and it helps you be visible in AI search. And there are other tools that are out there, but this is the one that we prefer. And it's pretty simple to use, and there's lots of ways that can help you. So it can help you on both sides. It can help you to produce content that's more visible, and it can also help you to understand insights from what's actually being published in the world and how that aligns with the work that you're doing. So it's simple. You enter a URL for any website, which could also be one of your research papers. And then LLM will automatically, I know it's LLM, ELELEM.ai. Really clever. And you can imagine how early in the AI boom that Tom Salvat, the CEO, had to be in order to get that domain name, but he did. Then LLM will optimize your content for LLMs. You can see a little screenshot here. It scores your paper. Well, firstly, it actually, and you can't see it here, but it will go, if you show it a web page, it will look at the page, all the content, and all of the additional links, including citations. And then you get to which one you want to focus on. It will score that piece of content according to a specific algorithm that will then show you where you start, and then it will give you suggestions on how you can improve it, and it will rescore it so you can see the before and after. I want to make sure that you know, like, you are in control of all the things that happen next with your content. So LLM reviews the full page and related links for each piece of content, and it recommends improvements. So it's like pushing the easy button for ensuring that your content is visible for LLMs. Then I love this part. Excuse me. You can analyzes performance. Sorry. All right. Edge of your seats, right? It'll analyze performance and allow you to implement insights. So what LLM does is it replicates how major like ChatGPT, Gemini, Claude, Perplexity, etc., view your content and the types of queries that people are using to get to your content, or vice versa. You can look at the queries that you think your content, your science, your research should be showing up for, the questions, and see whose content is showing up. It could be competitors, it could be completely types of organizations that are not even in your purview, but it will show you what ChatGPT, Gemini, Claude, Perplexity, et cetera, the LLMs, which sites they're going to answer those queries. It'll analyze the number and share of citations, mentions, and compares your sites to others that are answering the same questions. So again, it gives you an insight. It gives you insights. You're not blind anymore into what is showing up, whether how your content is performing or how other content is performing in spaces that you want to own. And number 4, your research becomes visible to LLMs by using a platform like LLM.ai. It shows you how your topics and content appear in LLM results, who else is publishing in your space, and it provides you with very, very, very specific tips on how to write and improve your content, as well as, which we're not going to talk about today, the technical background that's critical, the technical structure and infrastructure that's critical to ensure that the LLMs can even see the content and can then use it in responses. All right, so when it all works together, AI becomes a cohesive system that supports the entire research life cycle, from discovery to validation to dissemination to impact. We need to make sure the foundations are in place so that we can enable researchers and scientists to work faster, have more focused searching, summarizing, maintaining the rigor and the credibility is so critical, and that the industry demand provide strong and transparency of how conclusions are reached as far as what shows up in AI assistance, and structured and be surfaced by AI search. It's not visible. And when we do these things, the results are more studies and publications that forward and are available to people when they need them, where commercial opportunities, more grants, or to inform a mission or an individual might be possible to help solve a critical they may have. Products and policy decisions are informed, and it's really important to make sure and we maintain the what scientists and researchers set out to do. It allows for stronger commercial decisions that are grounded in high quality evidence, and it provides a clearer, faster path from research insight to real world impact, which I think we all want. All right, so let's talk about the impact. I think we need to think about it from both an individual and a society perspective. When scientists and researchers can reclaim work for the most rewarding scientific work and use AI to amplify your expertise, experience, and creativity, and disseminate credible research so that it's easier to find and trust, that results in breakthrough discoveries that reach people faster. Decisions in care, product development, policy are better informed by real, quality, accurate evidence, and more lives are touched by the treatments and technologies and interventions that are grounded in high quality science, which is what we all need. This is when we can give time back to researchers and scientists so that they can make some of the essential work easier and faster, and they can focus more on the human side of work. So some ideas to carry forward. Again, essential work remains the foundation. We can't shortcut searching, synthesizing, summarizing, but we can use AI to help us move faster when we're in the driver's seat. It's essential, it's critical to be thoughtful and purposeful when you use AI assistants. Don't use them like google.com. You've got to use them in a way that you would a trusted but less experienced assistant. Specialized AI tools can accelerate repetitive, high volume, or high stakes tasks. It's critical to make sure that your research and scientific findings are visible in AI-enabled search, and then effective and responsible AI can amplify scientific impact across each stage of the research lifecycle. So, viable synergy. Who are we and what else do we do? I shared a few enable organizations, as I said earlier, to effectively and responsibly AI tools for problems to meet tomorrow's demands, and do this through 5 lines. We start with strategy. We help to deliberate, like we talked about before, foundational AI solutions for life science. We also help build your custom AI infrastructure, which is critical, so that your solution within a trusted or environment and grow as you and then no AI complete or frankly effective without AI enablement and upskilling. So we'd love to do workshops to help scientists and researchers to use the tools that are available either off the shelf or custom. All right, so let's collaborate so that we can amplify scientific impact together. Ways to engage. We offer monthly AI gratis, no charge, free monthly AI and research office hours. These are just virtual sessions where we can come together and have conversations, working and not working. We can discuss some of the latest findings out there, and I really believe that we need to work together so that we can help everyone to amplify the impact. And if you want to have a more private session, one-on-one, we also offer complimentary AI strategy sessions. So the way that you can engage with that is you can find me on LinkedIn and send me a message, or you can email me at sunny@viablesynergy.com, or you can go to our website. You can look around. We've got a bunch of blog posts there for life sciences, where you can fill out the contact us form and we will get back to you. So again, thank you so much for the opportunity to be part of this incredible conference. Thank you for the chance to be able to share some thoughts about how we can amplify scientific impact with AI. And I really want to tell you how much I appreciate the work that each of you are doing to increase the scientific information and research that's getting out into the world so that we can all from you so much to meet each of you right next.
Hi, thank you, Sunny. Really, this was a great insights to a lot of tools, a lot of insights to AI, and it's great to have people like you who's doing the actual research and eliminating tools and strategies to be able to focus people in the right direction. It gave me a lot of insights, a lot of places to look, and I'll be following you and your company in the LinkedIn, and we'll see how we can work together for the different areas. But one of the things that if I am an executive who never ever used an AI technology and my company is still in the primitive stages, what would be your first advice? What is the one thing that, in one sentence, the advice that you would give it to me?
Murat, that is my favorite question. I didn't see it. It's my favorite question. So the very first, and we get this a lot, but the very first place that I think executives should start is by understanding the landscape. So we love to do what we call an opportunity and threat assessment. So we look at the landscape, we understand what's happening in their specific space and what's happening with their customers or their competitors from an AI adoption perspective. And then we do what we do an assessment that we call the three dimensions of value. So we look at how AI could improve productivity and is improving productivity in current products and services, and where they can innovate entirely new product, services, and business models. And then we help them devise a strategic and informed plan to know where they should actually invest in AI resources in each of those three areas. And it's critically important. People run to just looking at improving productivity, but that's only one step. It's actually kind of the first rung on the ladder of really effective AI adoption and use that can be transformative to an organization.
Excellent. Thank you very much, Sunny. Thank you for the session. And I would like to thank Glorium Technologies to enabling this conference and supporting it and sponsoring it. Global HealthTech Summit has been great for the last 5 years, and looking forward to the next year's one as well. But there's a lot of sessions. If you missed, please go back and watch it again when they publish it. And again, I would like to thank our moderator and also Glorium Technologies for sponsoring such an event. And I'm honored to be the host, and I learned a lot today, and I hope you did too. Please put your comments on LinkedIn or any of the interactions that you are doing with Glorium or any of the speakers. And we are looking forward to seeing you in the next webinar or seminar.